hypoxia. So that's going into that coaster, and then I flood it with epoxy on both sides so that you can't touch it and get shocked. It has that minimal layer of epoxy, so it won't directly knock you. And then the lead on there.
Oh,
yeah.
Richard,
it's not that it hurts. It's that you have these involuntary convulsions, and you tend to throw things or slap people or do one of the lane dance moves or something like that.
No, I've actually, well, you know, I've shocked myself once or twice as an electrical engineer, or technologist. So yeah, I understand exactly what you mean. But Richard, apparently there's a bunch of people waiting in the YouTube channel that's actually broadcast, but they can't see anything yet. But I noticed that Twitch is up and running. As far as I know,
Twitch is up and running, and YouTube just came up and running now.
Really?
But apparently there is something going on with YouTube's terms that you can't run both at the same time. One of our Lauren Berger just mentioned that in the YouTube.
I can't run two at the same time of what?
You can't run Twitch and YouTube at the same time in YouTube's terms.
Oh, really? Oh. I see. Well, that does.
Well, I'm
suck.
looking at it now. I'm looking at the same thing on the screen with a slight delay, but it's working on YouTube. 10 watching now. Nice.
Well, that's actually crazy. I'm glad it's working. All right.
Yeah, it seems like it's just... Okay, go ahead. Get down.
Well, obviously there's a delay on one of them over the other one. This is brand new for us, so we're just learning. So anyway, if it's live and it's working for some but not others, maybe that's a restriction that they're having, or is it our terms of use that we're violating?
No, it's YouTube's terms of usage that you can't stream to another platform apparently at the same time.
Ah, and it noticed that we are.
Well, that makes sense.
Yeah, it does.
But it seems to be working now.
Well,
if it stops working, you're going to have to choose either Twitch or YouTube.
Well, first things first. I'm just happy. I'm happy as
when
working
it comes to that.
as yeah. Well, I violated the terms of use. It was my first mistake. I'm sorry. So it does say the YouTube unable to connect. So it looks like it is trying to stop that one. So please direct people to Twitch because it seems to be up and running. And we'll work on fixing the... if we can get around this, we will. If we can't, we can't. Anyway, back to the interview. So, dude, did you just make a cross?
If that makes any difference.
Pardon?
I'm watching it on YouTube right now.
That's crazy.
That's an onk.
I noticed that.
That's awesome.
Oh yeah, that's beautiful.
Not help with any technical issues at all.
So do you change the gas itself to get the different colors, or is it the glass that changes the colors, or how do you make that happen?
Oh, this is something that I think ties right back to Electric Universe. Something that they talk about that no one knows about, which is the dark mode, glow mode, and arc mode plasma regimes. You guys heard about this yet?
Really?
Yes, we have.
Well, has Krista heard about it? That's the most important thing.
No.
New people.
Have new people heard about it? But yes, I do know exactly what you're talking about. Basically, the way that if you increase the voltage and amperage over through a plasma, it completely changes the characteristics of that plasma, and it's not linear. In fact, it's laughably non-linear.
Yes. So this is why it's fun making power supplies, because it's easy to drive slow mode stuff because it's constant load.
Right.
And right when you get into the glow mode arc mode boundary, it starts doing cool stuff, but it's all that cool stuff it's doing is loading back into the transformer. So it's an active, crazy active load, I guess, and it's not. I don't know how to describe, my electrical terms aren't very good, but a crazy reactive inductive load versus like a driving an element, a resistive load.
Well,
but so look at like a neon sign. A neon sign is neon in the glow mode.
Correct.
So,
or a fluorescent tube.
You can actually get like a neon sign to conduct electricity without actually lighting up too, which is, I think, not. I don't know if they know that in science, but that's part of the dark mode, glow mode, dark mode, which I find kind of strange. Like I can get.
Isn't that kind of like taking a fluorescent tube under a high tension wire and watching it light up in your hand?
Yeah, and that's you're going to get glow mode conduction. Like so, a vacuum tube's a good example of dark mode. So like a vacuum tube conducts electricity from the cathode to the plate inside, and you can't see that electricity conducting. There's no light being produced, but there's current flowing.
Right.
So like
a very low current in order.
Don't even pretend.
It ramps up to glow, right?
See, just in case you want to know what a tube is, for those of you at home, it's basically a BJT, which is a bijunction transistor, but it's a analog version of one. If you notice that effect that when you touch the side of the glass and how it allows the current to flow through the glass better, well, that principle is what you would basically do in a physical form to allow you to use a very small amount of current to control a large amount of current, and that's the principle behind a BJT or any of these. It's basically one of the basics that allow you to make more complex chips, basically. So they're really awesome, is what I'm saying.
We're going an analogy to a vacuum tube here, yeah?
Well, that's what they are, basically. You use a small amount of current, you basically touch the side of it, and you can get a current going through it, where you normally would not be able to if you didn't do it. And this is the principle of the vacuum tube that allowed them to use that. But of course, that's just one bit, if you know what I mean, like in the grand scheme of things.
Okay, you're kind of analogizing it to just like a switch. I thought that a BJT was more of a current-controlled switch versus a vacuum tube was more like a MOSFET, where it was more of a voltage-activated switch. But it all depends on
actually, to be perfectly frank, the fact that we were having this conversation tells you that we know generally what they are. They're basically use a small amount of something to control a much larger amount of something, and this allows you to have gradual control. And of course, that analog control allows you to have that wonderful, rich sound. Until the Neve console came out, nothing could beat a tube. So, Sound City. Great documentary.
Yeah, I'm totally fascinated by tubes for a couple of reasons. One, I want to make them someday. It's complicated, but I think I can do it. And two, you can see what's going on in there. So I make these Tesla coils, and you make them with the solid state stuff, and it just blows up and smoke comes out. And then you call somebody or get the meter out and have a little cry for a bit. But with the tubes, you can see, like, if it'll arc over and you'll see a flash, or you'll see it, instead of just going up in smoke, you'll see the plate glowing red. So I like it. It gives you a visual kind of feedback as to what's going on, versus with all the solid state stuff, I feel like I need some kind of electrical engineering degree and more scopes and probes and math. And
I remember actually what you just described. There's a scene in Sound City where it's a documentary. Basically, Sound City was closing down, and David Grohl bought the Neve console that was there that recorded like Fleetwood Mac and like tons of other artists were recorded there. And it's a perfect console. It cost about $74,000 at the time, which is approximately equivalent to like $1.5 million now. And this, so he bought that console, and he got to talk to Neve, the guy who designed it. And he said, he was talking about, it's just a basic microphone amplifier circuit, but the way that it is set up, it gives you an incredibly sweet sound. And this is the way that he described it. And this is the Neve himself, of course. And he starts going into more technical details. And just like you, David Grohl sits back and goes, you can see the little caption in the corner. It goes, "Does this guy know that I'm a high school dropout?" Like, because I don't have a clue what he's saying now. But I can appreciate the truth that is the analog of the tube, if you can make it that way. But I was just wondering about the gases themselves. That was my big thing, because I've noticed the different properties of different gases, the way that they flow inwards and outwards and go to the sides and so forth. It's wow.
Yes, easily distracted by squirrels.
Look at that.
So
Hey, Chris.
Yeah,
Can you hear me,
glow
Chris?
dark mode. So like we were starting, you're looking at that onk on the screen there, which is just xenon,
Right.
but it has the diffuse green feathers that are just the glowing. And then inside the body where the glass constricts, it's got that white arc. So that's like a good example of how to get an arc mode and a glow mode effect from the same gas. And then it's just really pressure dependent. So the lower the pressure you put in there of gas, the more everything wants to just glow. And then the more pressure you put in, the more it wants to do crazy. You get like glow mode filaments. And then all of a sudden they'll just go to that hard arc, and then it just pulls 3 times as much current and does crazy stuff. So it's just a matter of mixing the gases to get it to the right resistance. So like I can fill lamps and they'll pull more power than the driver will supply. And you just kind of got to find that sweet zone where it does something cool, but it doesn't pull 50 watts or 100 watts too much from the driver. Does that kind of answer your question?
Well,
and then use argon, neon, krypton, and xenon gas. And then you just make the vessel. That's a complicated part in itself, but
I mean, I could appreciate just looking at it how much effort goes into it. So, but when I was the reason I brought it up is because you watched our video that we had a little while ago with William Sosa, and he used gaseous mercury, and the way that it responded in reverse. Basically, instead of touching it and it goes to your fingers, it went away from you, and therefore you could sort of control it inside just by using pieces of metal inside the glass. I thought that it might be I mean, immediately when I thought of your work, I pictured you going, oh, with that technique I could make like something that looks like 2 different words and make it spell something different depending on what voltage I turn the gas up, if you were, like in the spray paint the side of a train type graffiti way, I guess, if you get my meaning.
Well, me and Bill kind of have a difference of opinion on how that phenomenon works. He's saying that different gases, or in the case that he's using mercury, he's saying that it will always repel. And certain gases will repel and certain gases will attract, which isn't a quality of the gas so much as a quality of the current density and the magnetic versus the dielectric energy. So I'm like, how do I, like if you take neon at a really low pressure and you run a really low current into it, you can get it to repel from your hand because your hand acts more as a magnetic field when the current's low. And then if you get enough current to go through the plasma, all of a sudden it'll just switch and it'll start attracting to your hand because
you stepped it up.
Science master, I don't know the exact definitions for it, but the way I look at it is the dielectric potential. Like it wants to seek ground more than it wants to be its own contained system. So to me, it's like this magnetic versus dielectric. How do you say it? Like there's this symbiosis between the two that always exists, and it can just go total left wing or total right wing. Does that kind of make sense?
No, it does.
So it's not so much the gas, but it's how much current you're putting through it and what the characteristics of the system are. So like I can get, if you put the right amount of neon or the right amount of any gas and you have a low enough current, I can get it so that you can push it away with your hand. And then you just turn the power up and all of a sudden it just attracts to your hand, just like most Tesla balls.
Okay, so basically you've pushed it beyond the, well, let's just say the Earth's electrical pressure, or the outside electrical pressure, or the ambient electrical pressure, to the point where now it doesn't care. You're trying to contain it. It still wants to get to ground. Too bad for you.
Maybe. My theory is that seeing as I'm powering it with AC, it can take like a loop from the anode I'm using, or wherever the electrode or power source that it's coupled to from the transformer, and it can either go out through the lamp and then back to there and cause so in that low current density mode, it's kind of self-confined and it doesn't care about coupling to the air as much. I don't know. It's all really confusing, and this is all kind of theory, and I'm trying to explain stuff that I see in lamps, and then I look at science, and they're like, oh, it's ionizing, and they have all these, and I'm like, that doesn't really help. But I see it kind of as being a contained magnetic system versus just reaches this point, and then it just wants to couple outside that system because it's needs more, I don't know, something.
Well, this is actually very interesting. William Armand Sosa responds to you immediately. I'm reading him on the on this. Actually, he's watching this video, and so hi, Will.
That's so cool. Hi, Will.
This is crazy because I didn't expect this. Anyway, he said electrostatic confinement, and then he said cations and anions. I will have to. I don't usually use those terms, so that's pretty cool.
Hey, tell Will to call in. Join the show.
Well, as long as he's on Skype, you can just add him to the call anytime you want. So if he does pop in, but anyway, it doesn't make any difference. That's not the whole point. I don't want to see an argument here. It's just nice to see you, Will, and we'll. So the electrostatic confinement, I can understand that he was, because if I'm not mistaken, and William will certainly correct me if I'm wrong, it was the metal around the base when it was coming out of the anode or cathode that helped confine this at the beginning, which I could understand because it's right up against the it's basically where it's coming out. It's turning it more into a beam.
Wouldn't that have been like the copper ring that looked like a flower head at the base of the tube?
Well, that's the whole Lotus thing, yeah. Anyway, that doesn't matter though. Still, I'm trying to interpret it for. So anyway, go on.
I see the analogy that he's using there is if you took a garden hose and you kind of put you took a cone and you cut the very tip of the cone off and you put that around the garden hose so that it sprayed, I don't know, 80% of the water out at 90 degrees in a plane to you, and then the little beam in the middle kept going straight.
Right.
I think he's coupling a lot of that energy that he's putting into that tube directly into the ground right where it's coming in, and then he's just having a little loop come through the middle, which is why it's going to be on the lower magnetic side, and it kind of explains to me why it's doing the repulsive.
No. You make a very interesting point, and only because when I think about it, if it was grounding out at that particular point, you're going to have, of course, not completely. I understand. There's an inductive coupling, a ring current, basically.
Capacitive coupling. So if you take a
lamp
with electrode, and then you put a piece of metal around the outside, it's going to capacitively couple, but it'll only couple so much. Like if you use a really small capacitor, it's not going to couple 100% of the energy. It's going to couple proportionately to your capacitor.
Well, the capacitance is basically area, and it's the over distance, and of course there's a constant thrown in there somewhere.
It's like when I make Tesla coils with a scope, and I don't know if it's safe or not. So I just put the probe close to the wire that I want to see what's on it. And it'll show up on my scope. So if you get that wire real close, you put a lot of wire real close, it'll take a lot of energy from there. If you pull it away, it'll reduce it. So it's kind of like a choke, kind of like a current choke in the sense that I kind of understand it. That makes sense?
Well, this is the basic principle that we've always used tubes for. I mean, in computers and so forth, that general principle, the ability to mechanically control the electrical flow.
Yeah, totally. So kind of
eventually electrically.
Stem of that lotus flower is kind of like a switch. Like if you change the capacitance from that point to ground, you'll change what's conducting inside the tube or the lamp versus what's conducting straight through that path to ground.
But I got to tell you, if I walked into that church and I saw these bunny rabbit ears, just like I saw his plasma snake in the Mercury, I'd worship it like a god. This is one of the things that I think even remotely, if the ancient Egyptian could pull something like this off, you'd be like, dudes, they're for realsies. You know what I mean? But
yeah, watching you guys' episode there on that Denderolite, and I was hoping that somebody would bring up the sprinkler pump.
Sprinkler pump?
Yeah, there's a pump that just uses glass tubing and mercury.
Okay.
And all you do is drop mercury. You hook up, maybe you can find it on the internet there and show people a diagram. It's pretty simple, but you just basically hook up a tubulation to the vessel that you're trying to pump, and then you just keep dropping mercury down the tubulation, and it kind of traps an air bubble and pulls it down. And it's not efficient. It's not like a modern pump, but like if you just let that run indefinitely, eventually that vessel will just light and it'll have trace mercury in it. So I'm like, I thought that was a huge.
What do we look up? What do we look up to find that?
I think it's called a sprinkler pump. Sometimes I look at words and then say them differently than they actually are in my head, though. So it might be a something pump. Here, let me go on Google. I'll see if I can find it quick. It's just like a gravity feed mercury pump.
All right, I'm wasting a lot of the screen time looking for William. William has Skype up, buddy. If you know William, go ahead and he says I have Skype up. Go ahead and call me. So give him a call. Unfortunately, if I do it, as you can see on the screen, it's just people. I'm occupying screen time.
There we go. Sprinkle, SPRENGEL. I just went to Wikipedia and put Springle pump, and it gives you a real quick. Here, maybe I can just do this. Does that work?
Yeah, we can see it.
You can see that. So yeah, if there's your lamp, and then you just put mercury in this chamber.
You can blow
and
that up there, Robert.
Just pumps all the air out of here and slowly pumps it out. And then you just seal this off, and there you got a trapped low pressure mercury vessel. And that's totally achievable. I love the fucking beep that, the Dendera scene, the whole Temple of Hathor and the Egyptian light. I'm like, I think this is totally feasible.
Well, and well, the thing is, and this is what I said to William, and thank you, buddy, for going in and trying to find him for us. He might have to actually relate to you through the YouTube channel or the Twitch channel, but either way, I noticed that it felt like this was this is at the time apparently where they were like selling spells, the same situation that you get when when the church was selling indulgences, that type of mentality, and it's the end of something. But it seemed that further back they were still able to hold on to this knowledge, which, to be perfectly frank, did not require any math to use. You just basically had to know how to control certain things, even if you didn't understand the actual mathematical principles. But in a way, the people who built, say, a pyramid or the pyramid clearly knew math. Just come on. So anyway, so to continue.
I think maybe math was just different. Like I love
whatever kind of math it was clearly different. But yeah.
But I'm like I like the expanding Earth theory. I always wondered how dinosaurs survived. You know, like a giraffe. You ever seen an autopsy of a giraffe? How does a Brachiosaurus walk around on land? That doesn't make any sense. And then I was like, oh, maybe if the Earth was smaller and gravity was less, that explains everything. So I'm like, who knows? Maybe the pyramids are from some pre-cataclysmic cycle, and just math was different. Maybe rocks didn't weigh as much when they built those things.
Oh, well, now you're hitting right beside my heart right there. That's a beautiful one.
Maybe they had those ice cream cones you smacked together and it resonated the rocks exploded.
My wonderful interpretation is a very simple one. Basically, if heat and the amount of heat changes the property of a material, should not the charge or the amount of charge also change the properties of material? And we can't ever leave Earth or this general orbit of the sun to change our actual potential that much. And we don't go and look for that. But although there is some evidence, like when you drop batteries or or you suspend capacitors, sometimes there's a change in, a potential gravity, apparently. So anyway, so these things seem to be maybe there, but until we, can shoot someone to Pluto and then watch it all mess up. I wondered if half the time we screw up is because the properties of the material were not the same anymore. So when they went to land on Mars, it was like, yeah, but this structure only has 30% the rigidity it should have, and it smack.
Ice harpoons. Why are the ice harpoons? Oh, rock. It's in a crack.
So William Sosa has joined. So
here he is.
Now we're gonna have to go. Does anyone have any boxing gloves? Anyway, no. So let's see how this goes. You mentioned something about cations and ions and the control of the actual throttle down by the lotus flower that we were obviously getting wrong. In your mind, this is the gist of what the thing that you were like, I must interject. So
yeah. Hello everybody. I'm not sure how good my voice is coming through.
Rich baritone, sort of like one of the doctors.
Okay. Well, as long as it's not breaking up.
No, it's great.
Hey, Chris.
Welcome back, Will.
Yeah.
Well,
welcome to the first live stream.
Yeah. The thing I would say about the dendrolite that I keep hearing kind of misrepresented even by Neil is the idea that the glass bulb itself has no electrodes in it at all. It's simply a glass bulb filled with mercury under low pressure. And the mercury, what I've come to learn from speaking with Chris, because Chris and I had some conversations through Facebook, the idea that there's glow mode, arc mode, dark mode. I hadn't given a lot of thought to any of that as it related to the dendrolite. Since then, I've come to realize that the dendrolite is in a glow mode and not in arc mode. And when you can get the mercury to get into glow mode, the mercury itself has a charge, an electrical charge, and I believe it's a negative charge. Right? It has more electrons than protons.
You're using alternating current.
Yeah, again,
it means the charge is changing back and forth.
No, that's not true of the gas itself. That may be true of the electricity going through it that actually, excites the mercury. But the mercury itself generates a charge of a negative charge, as opposed to neon, which creates a positive charge. And so that's why
relative to what's on the other side of the glass, I'm guessing, like air.
Well, no, relative to a neutral atom. A neutral atom has the same protons and neutrons, so it's neutral. If you could add an electron, then you have a negative charge, and if you could take away an electron, you have a positive charge.
I think the part you're trying to get at is what's left after the electricity takes what it's after, or I think it's called electronegativity.
And
So if you take an atom and you strip off one electron, there's a bunch of stuff left, which is what forms.
Right, and that may be fine, but the actual. Okay, I'm sorry.
The non-glowing part of the plasma. So like the plasma is, according to science anyway, the electrons that have been ripped off by the electricity and then fallen back on to the nucleus of the atoms.
That's not exactly true. It does just mean it just means ionized, really.
Right. And mercury doesn't ionize by stripping away an electron. Mercury ionizes by adding an electron. It actually grabs an electron out of the current flow, and gives itself a negative charge.
I see.
So it's not. It really doesn't care what it's being charged with. DC, one current, one way. As long as you get that mercury to actually glow, you have created a negatively charged plasma.
And we should be respectful, of course. Of course, mercury will have significant more weight to it as well. If it was creating sort of any inductive spin, its field should be stronger. But that's just a property of metal.
So the idea being is once that gas, that plasma has a charge, it will attract or repel, another charge. So if you have a Van de Graaff generator that creates a very strong negative charge, you'll repel that mercury plasma. And if you have a very strong positive charge, you will attract that plasma. And so that's why the Dendera light forms the way it does, is because the glass of the tube is an envelope of negative charge. And so it's the negative charge of the plasma inside, the mercury plasma, repels the side of the glass in all directions, not just one direction, in every direction. So if it's heading towards one end, it bounces off that end. That's why you have the head at one end. You can kind of imagine it like a rock in a stream. If you were to put a rock in a stream, you'd see this spot where it's kind of eddy current. You see these eddy currents. That's what happens at the head of the snake. You're seeing the eddy currents of this flow of mercury through that glass, flow of charge through the glass. So go ahead.
And I apologize for just interrupting there, but I do notice that in nebulae, especially the bipolar ones, the ones that we can see that are hourglass shaped, you can see that similar I guess you could say double layer as the head of your snake. Mm-hmm. I've noticed that a few times. Not exactly, but that same sort of, this is definitely a contained body. This is a separate and distinct from this part of the hourglass, like the butterfly nebula, for example.
Exactly. And so what is causing that double layer? I believe it's electrostatics. It's one gas is repelling the other gas. Some people think it's electricity creating magnetic fields that are separating them, and that may be true. I don't know, but the electrostatics is very rarely brought into the equation at all.
I actually bear with you on that one. During my we were at Bath just recently, and I want to stress that this doesn't actually encounter like when stresses get too high, and then you get like vortexes like tornadoes and hurricanes and pillars of fire and whatever must have been going on way back when. One of the things that did occur was I said, but I'm going to explain it in the terms of electrostatics, because we can all really kind of get our head around, just to prove to you that the Earth is a charged body, just straight up. And let me show you how. And you go through it sort of like on that level. But I noticed that you're holding something up, Chris. Can we blow up on Chris there, Robert? See what if you can do that. I don't even know you can. Oh my God.
I found the instructions.
Ah, okay. Robert, are you there? I don't know if Robert's there.
Hey, another thing that I noticed in the dendrolites that I don't think's ever been mentioned is, you know how they have the dual lamp configuration? Where there's either one,
right.
there's a set, they have both lamps. I think one of those snakes is male and one of those snakes is a female snake. You notice the heads are slightly different and one's going one way and the other one's going the other way. Put a little bit of thought into that, but I think there's something there that no one's kind of looked into yet.
No, but that is there is the if I'm not mistaken, and William had pointed out that it had something more to do with the hermetical versions of the sun and the moon, Mercury versus whatever the other gas was. I'm not even sure. I think it was hydrogen. I could be wrong.
It was called the day-night tube.
The day-night tube, right?
And so I assume that was the sun and the moon of alchemy, sulfur and mercury.
Right. Okay.
Well, I still think that there could be actual lamps and that could have been depicting a real thing, but I'm more in the camp that was a recording of what they learned in the last era or epoch or dynasty, and it wasn't so much of a pamphlet or a sales brochure for the lamp itself, because I see it as an analogy to how the whole system works, as the lamp or the glass being the envelope that we're in, or the ionosphere.
Well, I can see that. I've also heard.
And then, but he's like, where do you power these lamps? Did the Egyptians have Tesla coils? And I like all Bill's theories, and I like the oscillator circuit that he's got there. I think that one's great. But I think that the power source for the lamps, as far as depicted, is the sun, because it's the temple of Hathor, which is the solar temple. So I think I still see it more of a cosmogony tale, or as an analogy or a textbook, than a pamphlet for an actual lamp or service. You know what I mean?
I'm not denying that. In fact, I think that the possibility clearly existed that this. I mean, compared to what they must have had, this is a pale imitation, in my opinion. I mean, I'm talking about the failure of the Silver Age, as it begins to die down. The Golden Age itself, what that was, the skies were different. The world was different. Powering them. I mean, I'm not sure if they could make glass, because that's an actual kind of neat trick to do. So I'm not sure about that. But still, playing with electricity that was just humming through the world. I mean, we know what just happened when a few big comets come near the planet. The whole Earth shakes. Not because of the sonic boom when they explode, but in synchronicity of the flashes. Like, the whole Earth is piezoelectrically shaking from that. So if that was a common condition, taking advantage of that as a power source would seem as simple as taking advantage of a falling water source to spin a wheel.
Yeah, I hear you. I still see it kind of as an analogy. I'm like, I think human beings and life forms are the plasma in that lamp, and they're depicting life. So it's not, I don't see it as like a lamp.
This is not about the lamp anyway. This is about your stuff. I mean, I'm glad that we got William on to at least challenge you back on, like, well, what does he mean exactly? Because I didn't know, and I was not doing him justice, and clearly I was misrepresenting him. So, and Lael is laughing at me already. So
I ain't trying to trouble.
No, that's cool. I think it's hilarious. But still, this is still, if I think that I would speak for everyone here, that what you're doing and being able to get these different colors. Now, is this just, I mean, like you said, this is not just air. You're actually doing different things with different gases. Obviously, neon, xenon stuff, different colors, of course. But you use a Tesla coil. And now, you said AC, but do you mean AC with a huge DC offset? Or do you mean AC?
Yeah, so the system that drives it's basically just like a high frequency oscillator that drives the primary side of small transformer, and then the secondary side is one side's grounded to earth, and then the other side goes right into the lamp or into the whatever you're using as a coaster or a coupling capacitor. So as far as I understand it, it's just high voltage AC at 20 to 80 kilohertz. Most of the available drivers run, and the core, like some of them use a core, like a Tesla coil is an air core, which is far efficient, but great for isolating 100,000 volts.
Yeah.
The smaller transformers that are available, like through Amazing One, use a ferrite core.
Of course.
And ones will only do 20 to 50,000 cycles a second.
Well, it's because of the hysteresis, I'm assuming.
Yeah, you can only push so much frequency through the cores.
There's a small delay in switching them back and forth, the polarity of all the magnetism. But the reason I bring this up is because one of the things that Tesla coils usually do is they're always pushing outwards, as opposed to being a full swing back and forth like a power transformer. They would offset themselves completely so that the lowest they go down to is 0, and then they come back up to full, and then they go back down to 0 again, as opposed to going positive, negative, if you get my meaning.
I hear you. You're talking about the resonant rise buildup into
Basically,
the top
just
coil, yeah.
pounding DC out is what they're doing in a sine wave, more or less.
I hear what you're saying, just as a higher offset, so it's not like positive, negative 100,000 volts reference to ground, maybe reference to the top of the coil or something like that.
Actually, incidentally, your technique there that you had, or the thing that you had built there, William, is, if I'm not mistaken, that is exactly the same thing. It's on off, but it never hits 0. I mean, it goes to 0 alone. It never goes negative. So it's very similar to a Tesla coil, but just basically a magnet and I guess you use a tin can, which I thought that was pretty, and a nail. But still, I think that's, if Tesla coils usually do that, if that's the case, then you're getting more DC than you know, is all I was trying to say.
I hear you. That could be. I'm totally not an electronics engineer, and my oscilloscope skills are far from up to par. But the one thing I'd rebuke to that is that you can't really couple DC into the lamp, even if it's present. So the glass is dielectric, and it's only going to allow AC to pass through it. So unless you're using electrodes, I don't think there's...
clearly, no, you're right. You're right. No. What I meant by DC is I just meant the offset. The offset is off to one side. Basically, if you imagine 0 being the Earth, the transformers, most transformers power transformers in the world will go up and down, positive and negative. So when it says it's 110 volts or 120 volts, in actuality, it's going up 179 volts and down, or 169, I'm not sure, and then all the way back down to negative 169. And if you do the math, it basically works out to be 110 volts DC. Now, in your case, though, I was just thinking that it's basically going up to 300 and something, and then down to 0, and then up to 300 and something, and down to 0, as opposed to actually going into negatives, which is basically Tesla coil. Give Tesla coils that funky ability to really pound out the lightning. It wants to reach out, as opposed to going back and forth. Because if it was going back and forth, it would just hum. If you know what I mean. Like transformers don't shoot electric shocks, bolts everywhere is what I meant. So I think that's what's going on there. So you're getting the AC, but it's always above 0.
Okay.
I know that sounds strange. So someone should be, someone somewhere is probably going to go, I'm not saying it right, but but I am.
Yeah, know how to draw everything on a graph and reference everything to zero is one of the complicated things, and that's again what brings me back to electric universes. Because like, where's your ground reference for the universe? We just apply everything to Earth potential.
What most people don't even know is that Berkeley currents will flow in the opposite direction. And we've noticed this even in the smaller things like water lines, when they're little tiny, like when you get a water bridge between two beakers, and if you actually have red in one and green in the other, when they are crossing between each other, you can see the red goes up the middle and the green goes along the outside.
Oh, interesting. I haven't seen that yet.
Well, and that's akin to a Berkeley current. So if you have because it's force free, it's trying its best not to mess with its own electromagnetism. So when you end up having this current flowing, parts of it are going in one direction, but there will be parts going in the other, not unlike a tornado. So what is going on here? What's with the are you blowing the glass here? Is this the technique that you're using, or?
I'm not sure where we're at. I've drifted onto the dendrolite now. I was looking at floor plans of the Temple of Hathor. I keep looking at it and seeing all these Helmholtz cavities and trying to tie that into it somehow, but I haven't got there yet. Sorry, what are we looking at here? We're looking at a blow for a hookah.
Oh, okay, okay.
Yeah, I blow glass. I do borosilicate. People don't know what borosilicate is. It's like labware. So like I work with the guy at the university and do technical stuff, mostly out of clear.
Oh, so stuff that can resist certain heats and temperatures so that he can use them for his experiments?
Yeah, so there's a huge range of glass available, anywhere from soda lime to like window glass to what people refer to as Pyrex, which is, people think Pyrex is a type of glass, but it's a brand. But that's borosilicate, which is what I use. Don't get that confused with the cookware because it's not the same glass. It's tricky. But I use like a Cymax borosilicate, which is the same stuff that they'll make lab apparatus out of. So like flasks and jars and cylinders and stuff. So it's well suited to take the heat changes and the thermal shocks and all that stuff. And then it allows you to do way more intricate things than, say, most people think of glass blowing. They think of a hot shop where you have, like, there's a giant cauldron full of liquid glass and you reach in there with a pool cue kind of thing and you get some out and then you stick it in a beer keg that's on fire. So that's more of the traditional glass blowing, and that's soft glass. So real hard to get the intricate shapes and the wall seals and that kind of stuff with that glass. And then I have, sorry, my phone's dying. I gotta plug it in here.
No problem.
So, okay. Yeah, and then I got a lathe here. Maybe I can. So can you see that in my phone? There's my glass lathe.
Oh wow! So you actually you keep it spinning while it's semi-molten to keep it from drooping. Is that the technique, or?
Yeah, exactly. Gravity's either your biggest friend or your worst enemy when you're blowing glass. You just got to get along with it real fast. So yeah, the lathe just spins everything, and then that allows me to hold, like, some of the lamps I make start as 100 to 150 mil tubing, which comes as a 5-foot section, which weighs like a couple pounds. You can't physically do anything with that by hand, so you got to put it in the machine there, and then that. Yeah, let's see if my phone. So there we go. I turn that on and turn that up. And then that lets that rotate and that rotate. And then it's got a wheel. Oh. Smash my burner. Bring stuff together and apart, and then use chucks. I don't know if I'm in the camera here.
Oh, I'm seeing it.
And then that way I can hold, like, this will hold a 250 millimeter piece of something, all the way down to smaller sizes.
So
that makes everything out of tubes. And then I got if you can see, there's my bench torch. So there's another torch on the bench so that you can hold stuff in front of it, and then you're not necessarily on axis. Then everything goes in this kiln right here, and that makes it anneals or tempers everything to make it all, how do I easily say it, just makes the glass all not stressed. Takes the temper out of it so that it doesn't smash into a million pieces when you touch it. It just is as strong as possible. And then I'll put something in there. And the tricky part is that all the lamps need to get connected to the pump here. So there's this, you can see there, there's a small tube that comes out of the pump, and the manifold that has to connect to the piece inside the kiln, which makes it kind of tricky because then you got sometimes these gigantic pieces and it's on this little tiny tubulation this big, and you got to maneuver that into the kiln and get it onto the pump.
Have you seen those videos where they're playing with plasma in space, or showing how to make the rings of Saturn or something like that? I saw I'm not sure how long ago this was, but we were watching a Russian video on the International Space Station, and it was talking about plasma in like how things self-arrange. Oh
yeah, I saw that. That was awesome.
Well, the reason I brought it up is because I imagine that someone like yourself would be like, if only gravity wasn't a thing, what could I make?
I would love to see my lamps in space.
See? Because I know that if gravity was such a fickle mistress in my work, I would feel, what would it, to create without it, what could I do?
Please tell me what gravity is.
Do you, well, according to whom?
Right? No, it's a loaded question for sure.
You're in the wrong group for that one.
Well, no, you're actually probably in the right group, because at least you'll get more than one answer. See, I've learned a long time ago that when someone comes up and says, I have it all figured out, the only thing you be sure about is he's wrong. That's it. Like, that's
right. Every assumption I've ever made pretty much was wrong.
Well, maybe not assumption, but I mean everything all figured out. You probably have part of it, and that part of it is probably making you think that you know everything. And that's great. Tell us the part that you think you know, because that's the part that's probably going to lead us somewhere and help the entire human race. You might as well move from that point forward.
That's why I find this debate with William so interesting, is because to me, like, I sent a video to him there with a low pressure neon lamp.
Right.
That, like I was saying, if I could control the amount of current going into it, I can get that neon to either push away from your hand or come right towards your hand. I wonder if I can find that video.
However, that is a more neutral gas, though.
To me, I'm like, that's gravity. That's like, I'm either attracting or repelling that.
But it's not gravity, though.
Depending on the electrical
gravity
thing of the system. It's an electrical interaction.
Well, okay, gravity may be an electrical interaction, but one of the issues that we have is, of course, the magic that gravity has, that you can put yourself, well, I mean, all hard drives are wrapped in metal, and the reason they're wrapped in metal is because they have a Faraday cage. You want the Faraday cage so that you don't erase what's inside on those wonderful platters that are storing all that data. But that is why gravity is different, because you can't shield it. And that itself is the distinctive thing. Going to a subatomic level, which is what Wall does, because it makes a very good premise that these dipoles are occurring on a subatomic level, but can't actually leave the inside of the atom, so they can't flow like when you rub your hair on a balloon, and then there's a little bit of charge transfer and you can sort of stick it to a wall. But you can't do that with gravity, because all the charges are locked up inside of the molecular structure of the atom. They can't really get anywhere. That's his principle. I think that's a good idea, or at least way better than the bending of space and time. That's one. Or the other one that basically says, what's the other one that I really like that they try to do? Me and a few other people have had this debate, mental exercise. So I give Chris Burak a bucket with rope on it, and I go, Chris, spin this around in circles. Okay, and you're spinning this. I'm going to call that bucket the moon, and you're going to be the Earth. Okay, we're going to spin that, just spin it around. Now, are you actually wasting energy doing this? Well, yeah, holding that there it takes a bit of effort. Holding that spinning water as you're holding it there. So, if that is the case, then why isn't that happening in any other system? I mean, if you work on an electronic system, you know that there's a principle called the max power theorem. Basically, the heat is not generated at the speakers. The sound is coming at the speakers, but you must, if you're generating 500 watts of sound, you must burn 500 watts of heat to make that sound. And that's why your amplifiers get hot.
They sure do.
And that is why that happens. But the speakers don't. So this is the whole thing that basically I come back to is, well, what's powering gravity? Where is this coming from? Why is it happening? And it's not satisfactorily explained, even philosophically, just from those basic questions. And I'm sorry for seizing that, but anyone listening should go, yeah, damn. Sorry.
Yeah, someone explained to me how those bosons do it.
Yeah, I don't know, the Higgs and then the I don't know. Apparently, I can do anything. I can claim anything if I have $17 billion and a great big circle.
Well, you can call it anything you want, just not the ether.
Well, we're going to get into that already. How can everything in electrical engineering be based on something, and then you guys go, yeah, but we don't really need that. What? Wait a minute. What? Like what? Like no. We measured that. Yeah. But we measured this, and we have mass, and Newton beats, I guess, Maxwell.
But also, what is mass?
Well, this is where we get right back to charge, and we're sitting here having a conversation and going, what? I mean, we build with bricks now that are yay big, and then now we're going. Before we would build with bricks yay big, and then when it was the pyramids, we were building with about 2.5 to 3.5 tons. On the upside, 80 tons. But then you go back further and further, and you're at like 1,800, and suddenly 3,000 tons. And so the only thing that makes any sense is that it was fairly easy for them to do that. That's the only thing I could say. I mean, the situation on Earth must be such that it was not too hard to do that. And that alone is just blasphemy for people who go, no, we are the best that ever was. I mean, it's wrong. You know that they are wrong when this happens. When you go, well, you're the best people that ever were. Okay, build a pyramid. Just build the Great Pyramid Cheops right beside the second great one. Make it just as good as that one.
Well, they're the best at extrapolating indefinitely from a small.
I just mean they couldn't do it, clearly.
Assuming that everything's linear. But what's linear really?
No, because they're writing out catastrophe. If you write out catastrophe, you miss everything. I mean, I don't mean to go all Velikovskyan, but I mean, Jesus, listen to the man once in a while. I mean, he had something to say. Guess what happened? The skies were on fire. Shit rained down. Chicken Little was screaming,
Yeah, I went back and reread the Bible after I read Velikovsky. Makes more sense. And the whole the Purple Dawn Ganymede hypothesis.
You want to blow your mind? Have you read the Apocrypha?
I don't think so.
Do you know what it is?
Woo.
My mother has a copy of it, so I loved it. Basically, it's the one that it's not sort of like if you think of the Old Testament as Jewish and you think of the New Testament as Christian, the Apocrypha is like these few hundred years where angels were like really prevalent and walking around and doing shit. And that and that's when you get like the Semyaza hanging upside down by one leg, and that becomes, of course, a tarot card, the hangman and all this other stuff. like where all that reaches into. And I don't really, trust me. I mean, it is beyond my strengths, bailiwick or whatever. But still, one cannot but think about that. I mean, when you're talking about stuff like that we just discussed. So.
It's reminding me of the Anunnaki.
Well, there you go. You see.
I want to know what's in the bag, man.
Well, did you not? Oh, well, guess what? You're going to be very happy. I learned what was in the bag. I was hanging out with Andy Hall, and we were going over Göbekli Tepe, and we were like, "What's in the bag, dude? What's in the bag?" And then, of course,
what's in the bag?
No. Don't worry. Brad Pitt was there, and Kevin Spacey did not look concerned at all. But
Perfect.
clearly, I'm just telling you right now, Morgan Freeman was shitting himself because he knew it was going to happen. But the point is, the bag was...
He's selling those pine cones for gold, right?
Well, there's another thing that we could probably talk about. But these ideas of the arcs, which are like prominences, but they were on the Earth, were like the carps that were seen in China that were diving across the hemispheres. They were above the atmosphere. They were above the ionosphere, so they looked like there was stuff below them, like this sheet. And these loops there repeat in several cases. Now, I found that to be brilliant. And of course, we understand that there has to be a circuit. I mean, there's something happening in the skies that will induce a secondary current. And then, of course, those currents will induce a secondary current, and yada, 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 yada. And of course, eventually we get those Arches monument there, which this bugger there, Robert, is really awesome because he gets to live right beside that. I got to see one of them. He's probably seen 2,500 of them. And now he won't even answer.
Can I add something?
Oh yeah, he had to go. I'm sorry.
Neil?
No, of course, I'm done. Please go ahead.
I just typed in loops or buckhorns not connected to the rear of the buck. Those ancient pictures of stags, square stags, sometimes with long legs, sometimes with short legs. These are all electrical discharges. That bag is an electrical discharge that was witnessed by everybody on the planet, up in the skies. Doubt. That's what I've been saying for months and months and months now since I figured it out.
So what you're telling me, Richard, and I don't mean to be insulting you, but I kind of am when I go. So basically what you're saying is you've discovered the electric universe. Congratulations.
No, I've discovered a small piece of the
electric
universe. I figured it out in my own brain.
Well, I hope you have, because trust me, there's every time I think that I have it figured out, some guy goes, "Oh, have you read Eduardo's work? Oh, have you read Bill Mullen's work?" Oh, I'm like, okay, clearly I have a reading list that I have to catch up on.
Kind of like the day that I figured out that the Indian chiefs and the main important people in the tribe that wear that feathered headdress, that's a representation of Mars, Venus, and Saturn, the polar configuration when Mars was in full cometary display, looking like feathers wrapping around Saturn, and Mars sitting in front of Venus looking like a face.
Actually, I'll tell you something that
when I found that out, it blew my mind. I'm pretty sure that's what it is. Sorry, go ahead.
No, that's cool. That's cool. I actually was like cool with that, but the part that always blew me away was that if you look at the headdresses of the Roman soldiers, I mean, some old, thing you might have flipped through in grade 4 or whatever, and you go look at the Native American headdresses, they're identical. The mohawks versus the ones that are wide and going across the outside with all the feathers. And of course, it depends. The wide ones that go across the sides were the ones that were the leaders. They were the centurions versus the other men that were the ones with the mohawks. They were the ones with that kind of thing. I was like,
the leaders of the warriors, they had bull horns, and the shamans, they wore bull horns. Well, that's Saturn, the sun shining on Saturn, and we get the crescent and the star. They didn't represent the star; they just represented the bull horns.
See, and every time you talk about that, I'm like, but but I still believe in the Argo because now Jim's completely sold me. So now I'm like, when was that?
Well, why couldn't it have been both?
Well, that's what I mean. I clearly think that there has been multiple catastrophes, and to be perfectly frank, I'm just happy that the human species is here to have a debate about it because it looks like
we
we're
have
still
proof
living
of
through
5 of them in the Middle East. They've dug down and they've found 5 destructive events, and not only that, they found multiple events everywhere around the world, and I think most of them equal up to 5.
Well, now you've convinced me that I have to do some archaeology, but still, this is about Chris. So, what are you doing? What is this device that you're trying to build here? I'm picturing like some sort of organ made for aliens.
Oh, device? Oh, there's just a bunch of sconces on my wall.
Just a bunch of sconces on the wall. Do you know what happened when Daniel Jackson showed up on Stargate Atlantis and they just had to find 3 sconces? They found They found Janus's secret lab, and then that's when the evil Asgard showed up. I'm telling you, don't mess with this stuff.
I gotta watch all these shows.
Yeah, you probably do. I'm just a geek, but a nerd as well. I can't help it. It's just the way I am. But still, someone with a gift or a good question, please speak up to our friend here, and including William, if you have any feedback on what Chris's points have been, because I guarantee that your education level. I mean, since you're both experimentalists, this is where you can get to some really good conversation. I'm betting. So. I'm being quiet now, is what I'm saying. Someone else talk.
Somebody earlier in the chat said, "Do you have a charge plate?" This is way earlier in the comments. A charge plate that's causing the charge, if you will. I have to go back up and look. And you kind of explained it, but this is way earlier in the chat. I'm trying to go back up and get to it. Guy asked a really good question. I'm going back. It's almost at the beginning.
Look for Don.
Can you speak about
His
the
name was
details
Don.
of the? Here you go, Don. Don Kress, can you speak about the details of the apparatus that creates the plasma glow? Does it sit on a charged plate? I mean, you were explaining it, and he may have caught it or came on a little later, but that was a good question from the listening audience or viewing audience, I would say. Explain the details of the apparatus that creates the plasma glow, and does it sit on a charged plate?
So, as far as I can easily describe it, the transformer is basically a Tesla coil. So there's a vacuum tube Tesla coil I built, and then there's a little solid state Tesla coil. And then the drivers, there's another vacuum tube Tesla coil. And then this is what's available commercially now from that Amazing One place. And that's basically the same as this, only they shut it off so I don't arc to my phone. So there's just a little transformer in the back. And then it's kind of the same concept. That white thing that you see there is the secondary of the Tesla coil. So same as this part in here, the part that shoots the sparks. And it's just potted inside of I don't know, some epoxy or something. And then that can run either right into an electrode. So I have these neon electrodes, but for borosilicate glass, so I can couple right into the inside of the lamp, kind of like a neon sign using those. Or always need fuses. Or for the wireless lamps, what we're basically doing is taking this top load here, little toroid, and we're just basically extending it into one of these coasters. which is basically a piece of metal perf screen that I just put inside of epoxy or inside of a piece of wood that I make on my wood lathe there. And then that way, I don't know if you can see that, but that way you can't actually touch the electrode, so it'll shock you a little bit, but it won't really get you. And then you just put the lamp right on top of there. How's that? Did that answer any questions?
I think that was pretty straightforward. That is an awesome coaster. It looks like a Capri coaster. If I'm seeing it right.
That was amazing looking beetle.
Was really nice too, man. Wow.
Oh, thanks. Yeah, the images on there. Well, that's the problem with art is you can keep doing it and putting more stuff, and then
I guess my question then would be is how's your electric bill? I'm just saying. I mean, is it efficient?
Here's my oxygen system. Got 1, 2, 3, 4, 5, 6, 7 machines and another pump, and it's nasty. It's like $650 a month.
Woohoo! Wow, that's more than pumping the AC like for a month straight, not turning it off for any reason.
But that's not so much as a current draw for the lamps. My electric bills for producing oxygen. I used to buy oxygen in tanks, but like I spent $12,000 on oxygen for a couple of years, and then I was like, that's too much. So now I got that crazy setup that I can make it at home, but that draws a little bit of current. And then my kilns are pretty current intensive, but that's about it.
Did you say you're selling the coils yourself?
I'm not quite there yet.
Okay.
I'm making them myself and trying to get to the point where I can make something that I know is going to be safe and last 10 years and not cause any problems. But right now I'm trying to build more just to understand what I'm doing.
Yeah,
like,
I understand that.
You can try and learn how a Tesla coil works without building one, but I'm like, you won't help anybody build one that way.
Right. Because I heard you mention a company that you could get them from. Did I hear you correctly?
Yeah, if you go to there's a place called Amazing One, amazing1thenumeral.com. They sell all kinds of crazy stuff.
Yeah, this is good stuff to see citizen scientists, if you will, just doing this. And we're running into more people, seems like daily, that are just in the lab, in their houses, just, going in. I'm amazed. I am. I really am.
Well, here, I'll take you for a tour downstairs where I keep all my transformers.
Oh, wow. And I guess I'm looking at someone to rebuild a Torello too. Who's going to be the next?
Yeah, that's one of the things that I've always been into. I think Birkeland's fascinating. So I don't know if you can see here, there's some extra lamps. There's some lamps I got left. There's my transformer collection.
Nice. Yeah, I'm always talking to people about the electric view and the interesting folks that we're meeting, and this is the first step, if you will, to prove how things work. Pretty much taking the bull by the horns and doing it. And I appreciate guys like you that we run into that are just doing it. Just outright doing it. I mean, I'm at the level where I know I could take an old fuse if it blows, and I can put a piece of aluminum foil around it and just get a copper wire and pray that when I pop the fuse back into an amplifier, I won't blow it up and it'll last, through the night. So that's about the extent of it with me. But you guys go in, I mean, you guys are going in.
Yeah. Send money for fuses.
Right. Now, if you're DJing, because I DJ, if you're out, boom, a fuse blows. I mean, something's wrong with your equipment. But how do you get through the day? It was like, this is the 80s. Get a piece of aluminum foil. Get a piece of copper wire. Hurry up. Quick, pop it in. And just hope that you used enough wire And if you use too much, obviously it would take longer to blow the fuse. And if you didn't use enough, it would blow again. So you just had to kind of guess. But it would always work. I never had a problem, but that's about the extent of me being an experimentalist. You know, taking things apart when we were kids. But you guys really, this is impressive to me. You know, this is very impressive to me. People have this stuff in their houses, like, wow, good stuff. Good stuff.
Well, thanks.
Oh yeah.
Yeah, I don't know any of the technical terms, but most stuff doesn't blow up now.
Right.
Turn it on, it's come out. So
that's your goal, is just as long as it doesn't blow up.
That was my goal for the first year. The first Tesla I made took 5 weeks, and oh man, you had to fix it a couple times.
I got to tell you, there are some really, really good experimenters out there that I have tried to work with, and this is in no way, but you've exemplified the exact issue that happens. And if you ever, if for some reason there's this, you're like thinking that you're explaining this to some engineer, right? And suddenly they don't want to even talk to you anymore. Okay.
Yeah, I get that.
It's not necessarily because they don't really want to hear what you have to say. The moment, like, for example, if I don't report you, you know what I mean? Like if I tell you to do something as a friend, like I say, no, have you tried blowing this up with your machine? You know, then I am taking responsibility, and therefore I can be in trouble because I'm the guy who should know better than let somebody play around with 40,000 volts.
But I want to share the liability with you.
Yep, it don't matter. The government don't care. But anyway, if you ever hear that sometimes, that might be sometimes a reaction. So but if you talk to other people who are just learning before they get that drilled into their head, you'll find they're much more receptive, I'm sure.
No, I hear you. Yeah, no, there's a lot. And I'm like, I got into this and I thought I kind of had an understanding of electricity because I'm an audio addict. I got amplifiers and subwoofers, and I've been doing stereos for years. But that didn't really help at all. Like super basics, like positive, negative. And I'm like, I know about the mains and the grid and that kind of stuff, but
you know how a speaker works, right?
And resonant frequencies, and like I try and ask people what resonance means to them, and you should see the different definitions people give me.
Actually, yeah, that's almost all of them are wrong. Speaking of which, something that you're probably going to love. I had the opportunity this past weekend to be at the symposium. And at this symposium, which was after the Bath Conference, EU 2019, this wonderful gentleman named Jonathan Nava, who you might know him from the boards. Okay.
Bell with me.
Like, I'm sure the NAVA, not hard to figure out. So if you see Jonathan Nava, he's on the Electric View page. So if you're looking, you see him there. Now, the reason I bring him up is because I specifically went, this is working. And he's like, yes. I'm watching it happen right now. Yes. And I'm looking with my own 2 friggin' eyes on what I'm looking at here. Okay. And it seems to be a pair of Tesla coils at the exact same diameter that are creating a resonance frequency between each other and are broadcasting power and letting up another source. Now, this is the part I was talking about earlier about the speaker. Okay, the speaker being not the speaker is being driven, but the heat is being generated elsewhere in the that's the max power theorem.
Well, depending on your amplifier and your voice coil, you're still going to get heat in a voice coil if you're driving it hard.
No, of course. But what I'm saying is that the maximum amount of power you can ever hit out of your speakers in an ideal situation is equal to the amount of heat you're generating inside the amplifier. That is the max power theorem situation. You can't get any more than that. You can never have 700 for 300. You have to have the heat has to come from somewhere. You know what I mean? Otherwise, it's not watts. Otherwise, the heat isn't burning. You know what I mean? That's just.
I hear your theory, but I'm like, what
No,
about
no,
Class
it's
D?
not my theory. Trust me. Just type in max power theorem. You're done. You know, it's just what it is. You've done it a million times. It's like when you're impedance matching. You know, it's very similar to that when you're hooking up stereo speakers. You want to make sure you got the right impedance, because basically what you're saying is that if you change the impedance of one, basically you've knocked it out of 50-50 alignment. You're dropping it down to like 66-33, or heaven forbid 75-25. You know, you're basically, because you got 4 ohms on this and 1 ohm on that. You know what I mean? So you're like, that's wrong. It won't work. You know, you need to impedance match it. You need to make sure they get the right exact ohmage of the same speakers. Anyway, you know what I'm talking about. Hopefully you do. So in fact, right now I have no idea where I was going with that. Apparently, I've lost my train of thought, but it was a wonderful expose of impedance matching.
I would like to find out, Chris, do you have a YouTube channel?
Oh, he does.
A couple of people might be interested in finding the address for that. I'll post it in YouTube or in the live chat in YouTube.
Barracuda Glass. They actually, some people have already found him. So.
Okay, yeah, I still go with Barracuda Glass because when the glass industry started, I don't know if everybody's familiar with Operation Pipe Dreams, but I used to make pipes and bongs and stuff to make a living. So way back in the day, nobody kind of put their real name out. Nowadays, it's kind of past that, but everybody used to have their secret glassblower's identity.
What country are you in, by the way?
I'm in Canada, Calgary.
Well,
but in the States, this was a huge thing. So that's kind of why all the glassblowers have this alias name, versus most common artists will just be like, I'm Chris Burak.
Right.
But what I'm getting at is, if you want to find me, Barracuda Glass. And if you can't remember Barracuda and you can remember my last name, that's where Burak Barracuda is the link there.
Oh, I'm pretty sure they know, because it says Chris Burak from Barracuda Glass Talks Electric Universe on the Electric View 23 watching live now, right on the screen. So yeah, I think we're doing good.
I just posted it in the live chat for those that don't know.
There we go. We got it covered.
All handled.
You can find I got a YouTube channel with some videos. Not everything gets up there. I take absolutely horrible videos for some reason, so I get Jody to help me, the wife. So thanks, Jody, for doing all the videos. Those are all because she's so great.
Just in case there's anyone wondering, by the way, sorry, just in case anyone's wondering, it's not even decriminalized here. It's just legal in Canada, so it doesn't matter. Anyway, moving on.
And Chris, that's why they called them the better half?
Yeah.
Yeah. Yes,
right?
That is true. By the way, if you're ever interested in some of these improving your video, there's apparently some attachments. I didn't even know that they existed. That wonderful gentleman, David Brown, Electric Universe Eyes, he bought one that's a magnifying glass. That's what he uses to really get up close, so he doesn't have to actually use really large arcs. Much safer, clearly, and zoom right in on them. I'm not expecting that, of course, of yourself, but I'm sure there's things like that you should be able to attach to whatever phone you have. I mean, things are it's that kind of world we live in now. So I'm sure there's people on the chat that can probably tell you about it.
Yeah, it's tricky.
I do believe he's talking about a USB-driven microphone or a microscope.
Well, whatever. I mean, he doesn't need a microscope. He needs like a good quality, like, zoom in.
I think one of the issues with taking videos of plasma is that your camera tries to autofocus on it all the time. It just messes it up. So your camera doesn't know where to focus. So Jody knows how to.
I had the same problem while I was at the conference. I just locked it. Like, I just basically clicked on a part of the screen and said, "This is my focus. That's it. Screw off. Stop trying to fix it. I don't need you to fix it. Stop trying to fix it."
Yeah, I'm not as good at anything that involves keyboards or shortcut keys or focusing the frame properly.
By the way, I stood on King Arthur's tomb while I was there. So blasphemy. I'm going to hell, and you're all coming with me.
Woo!
So speaking of hell,
They're laughing.
So Krista, are you there? Are you actually listening? Are you actually there?
I'm here.
Well, hi. We didn't actually get a chance to hear from you so far. So, can you tell me the 3 things that you are most confused about in our conversation so far?
Ooh, good question.
Top 3 confused items. Well, I can tell you the top 3 things that I cannot wait to dig into a little bit deeper. And you were spot on with the arc glow dark modes of plasma. I'm really curious about that. And then some of the things that I didn't quite catch because the conversation got sort of dappled as multiple people were speaking simultaneously, but how the change, I guess, in pressure and heat can affect the way the different modes shift. And
we're going so far as to say that it can even affect gravity. Like it's, yeah.
Okay, so that was completely lost on me.
Well, we just sort of alluded to it. Don't worry.
Okay.
Changing mass was what he said. And then what is mass? So that applies gravity, of course. So.
Exactly. But I mean, I would say that for the most part, it's been really clear, completely fascinating. Chris, your work is spectacular. It's just stunning. I've been checking out like your YouTube and some of the other things while we've been listening. And yeah, gosh, thanks so much for diving into that and doing the work you're doing.
Thank you.
Mm-hmm.
Well, actually, I'm very glad to hear it, Krista. Krista, one of the reasons that she's here is she wrote to the Thunderbolts project, and it was like I was talking to them, and they were like, perhaps Krista could learn, like direct her in someone who could help her. I was like, actually, we can help her, and I said, just come on to the show and start asking questions, because one of the problems that we have is that. And Gareth noticed this when we were in the episode just a few episodes back, Seeing is Believing, where it was you forget that not everyone can say double layer, not everyone knows what every one of these terms mean, or capacitor even, or plasma tube, or BJT, or whatever the heck I was just babbling about. But who has a screen right now? Who has a screen? Who is driving? Richard?
Not me.
Is it Robert or Richard? Or
I don't think it's me. It might be Robert.
Is Robert? Are you driving?
He might be AFK because I think he said he had to go.
Yeah, but how can he be driving if he's AFK? You see, that's just insane.
Well, yeah, in 2:31 he said, "I have to go. Everybody, let the PC stay on driving."
Who wants to drive? Say yes. We're going to go with Richard, because you'll hate me, Richard. So, Richard, grab the screen. Yay! Look, what the heck
I'm
is...
not ready to fly the Falcon yet.
Okay.
Oh my God!
I don't know what to do now.
Okay, just blow it up to full screen, and then start searching for things. Bring Google over, or bring that over, and I want you to look for stuff. You're doing pretty good so far, by the way.
I'm scared.
You're scared?
I'm scared.
That's why I didn't say nothing myself. I'm not ready to drive the Falcon.
There, see? Now look at that. We got this whole great big thing coming. So make that the full screen.
Oh my goodness! Okay.
Oh my God!
Here we
Now
go.
look what you've done. You've screwed everything up. The world is ending. No, just go ahead and just make it full screen, bud. Just boom.
Make this full screen.
Yeah, that window. Just boom. Just boom. The sun is now full screen. Go. Boom.
Hang on a second. My thing is. I can't get to the tabs up top for some reason.
Okay,
I
just
think
pull
I
the
pulled it
whole
up
thing.
too high.
Just pull the whole thing down. This is actually hilarious that you're having this trouble. You're like, I can't pull it. There you go.
Well, I had to go and reach over from my other screen because I couldn't reach it on this other screen.
You had to do a reach around. Okay, I gotcha.
Oh my god.
No, I wasn't thinking that at all. I don't know what you're thinking. Can you yeah, blow it up to just hit the
full screen.
Yeah, the full screen. Just double click or whatever, Okay.
Oh, and I wanted to.
There it is, right there.
Who was that?
That's what I want you to do it.
That's where I was going. I was trying to post that into Skype somehow.
You don't have to now. Now you're sharing. Krista,
I know, right?
Krista, Richard was thinking exactly along the lines. This is exactly what. Now look what you did, Richard.
Oh, sorry.
My bad. I can't buy good help. Anyway, so
good help.
This right here, though, gives you your voltage versus your amperage. And as you can see, as Chris Burak was saying, it is laughably nonlinear. There is no point on that screen. So as you can see, at certain points, for example, between F and G, you notice it goes down as the amperage goes up. That means that it will reduce the surface area or filament. And this is basically the same thing. Arc mode does it severely. And so things like the current saturation region, the B to C area, that is where Geiger counters work, where it goes click, 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 click to let you know that you're going to die. And the Townsend discharge thing, that is basically where you're getting your that's where your Van de Graaff generators or your St. Elmo's fire or your Tesla coils sort of work at. Although if they get cranked right up, they go right into arc mode. As you can see, it's not, it's just a matter of current per square meter. So, and that's what A means, current density. So.
I just wanted to say, you can think of them as modes within modes. It's kind of lifelike almost. I'm sorry, I just wanted to say that.
Obviously, some people on the YouTube are getting the jokes. But if you guys want to have any questions, by the way, feel free, because we're actually on Don. If I'm not mistaken, this is Don Scott's page. If I'm not mistaken.
Nobody gets my jokes.
Really? Try
Usually.
one.
Yeah, Neil, a real world example to make it simple. Because I might have a friend that was listening, and we were kind of talking about this earlier.
Scroll
Not
slower,
to make it complicated,
Richard.
but I'm a DJ. So if I have 4 speakers that push out 500 watts per speaker at 8 ohms. On the back of my amplifier, I have a button to push where I can run the speakers at 1,000 watts apiece at 4 ohms, but I have to do what's called bridge them. Literally, one wire comes out of the amplifier, goes into one speaker, to the next speaker, to the next speaker, to the next speaker.
Right.
Then you make a loop back to the amp. The amp gets hot, my man. When I say it gets hot, it gets really hot because now I've doubled the power output.
Oh yeah.
The ohms are lower. Impedance is lower,
well, that's,
but now I'm just
but
that's driving now.
That's
so now
why
I'm driving
it can do
4,000 watts. Yeah, I'm driving it. And when I say hot, I used to have one of those stand-up fans like you have in your house, and I used to just put a stand-up fan right behind the amp because the fans are built into it. Just weren't enough. When I say hot, I mean really hot. So that's what's driving the speaker essentially. It's the energy, if you want to call it that, being generated from the amp itself.
Stop, Richard.
I know.
Loading your amp down.
Richard, right there. Click on that one. Okay, that's all you need to know. So I know it sounds weird, but resistance is in one direction. That's your heat. Your magnetic inductance is in the other direction. And the relationship between the two is basically your electrical impedance. And that's what makes things get really hot. Anyway, still, but you're not wrong, Sean. It is.
Yeah, it's like this, it puts a tremendous load on the amp. So the amp's going to get hot. It just is.
Well, you're doubling the voltage basically by bridging the two together.
Yeah. Yeah, it's like, and I've learned not to do that if I don't have to, because I have blown speakers apart. I mean, literally, I would stick them all together so I could get a little bit more sound pressure level with all four being together. But you can, it's really dangerous, if you will, from a standpoint of you can damage your equipment because you're really generating a lot of heat and power, doubling it. So that's just something to just throw in there to kind of keep it simple, if it was simple. If it was,
you can go ahead, Robert, and take over again. Richard was just taking over while you were gone. We were looking for a particular thing called electrical impedance, and basically Don Scott's that wonderful VA curve or VI curve, volts versus amps in the plasma, which obviously you weren't able to do, but it still worked great until that point. So. Kudos.
Well, because I shut Skype down.
It's all good, dude.
I got
Don't worry
so
about
much
it.
going on.
Don't worry about it. So go ahead, Robert, if you want. So now we're at this. Basically, here we are now. So now we heard from Krista. Derek, is there anything that you want to ask?
Can you guys hear me?
No, we can't hear you at all. You're an alien.
No, well, it sounds like sounds like you can. Well, I had to switch from my phone to my computer, so I wasn't sure if the sound was going to get messed up or not.
It works like a charm.
And I did have to step out, so for a little while.
I'm glad we caught you.
I missed quite a bit.
Hey, same here. I was on autopilot driving this thing.
But no, this is awesome, Chris. What you're doing is pretty badass, if I could say that. But again, not having a scientific background, I don't know what to say other than I have been watching some of the stuff on that Sapphire's doing. And go ahead.
Oh, I was just saying I love Sapphire Project.
Yeah, I mean, so like, how does that like? Are you trying to get to that level? I mean, like, or can you explain like the difference between their goals and your goals? Or, I mean, and again, this is coming from somebody that doesn't have that technical knowledge. So forgive me for being pretty lame here.
Well, I'm just trying to, I guess not explain, like Sapphire to me is trying to stick probes into the plasma and chart it and tell you where the voltage drops are and find what's the word, the cell walls, they talk
double
about
layers.
Yeah,
the double layers. Yeah.
So yeah, they're trying, as far as I understand, they're trying to actually physically measure where those are and how they work, which I don't think that the scientific model really has a current understanding of.
Yeah.
So I think that's awesome, but I'm not at the point where I'm trying to stick probes in there and get any numbers. I'm just trying to make lamps that help me make sense of all this.
Gotcha.
So I'm still at the point where I'm like everything you fill is different. So there's really no recipe to any of this. And I'm like, you can look online and see what other people have done, but if you put a certain recipe in the wrong size vessel, it's totally different. So there's just a ton of variables. So I'm still in the point where I'm just trying to learn to the point where I can predict what I'm doing.
Right.
Sometimes I'll make a shape, I'll try and fill it, and it just won't do what I thought. And then you just want to smash everything, and then you take an hour and put some different gas in there and just mess with it, and then you get a new, how it does that. And then you kind of just got to incorporate that into your plans. It's a lot like glass blowing, I find. Electronics and glass blowing is you just kind of walk the path, and when the path falls away, you just don't walk there anymore, and eventually you can go anywhere you want. As long as you know what doesn't work.
You and I
go around
remember circuitries very differently then.
Well, I kind of see how I've been doing Tesla coils is it either works how I thought, or I assumed something wrong, and I
Oh,
gotta
you're
go.
playing with plasma. I completely understand the variables that you are suddenly playing with. But there is that certain sense of certainty that they give you when you build something and you're like, holy crap, it works. You know, like from scratch or something, you know, like that kind of thing. And I'm sure you've experienced that yourself when you're like,
Yeah,
oh my God,
used...
everything's working great. You know, like it's not breaking. I expected this to already fail twice, but here it goes, you know.
Yeah, like the first time I used Tesla Coil Java Pro or whatever to actually calculate stuff, and then put my frequency meter out, and I was like, it's actually doing the frequency it said. Versus before, I was kind of less math inclined, and I'd just tune it. And then once it works, I'd be like, I don't know what frequency it's at or how many watts or what the impedance is. But look, sparks coming out. Win. So I'm kind of getting to the point where I can kind of predict.
See you later, William. Thanks for being here. William is supposed to have to take off.
The other thing I was going to say, if you want to show some charts and graphs, one that really helps is Paschen's law.
Oh.
Which is the electrical breakdown potential of different gases versus voltage, which is kind of helps explain how, like, so if you take a Tesla coil that's making, say, 3-inch sparks in air, and you replace that with a pressure at a certain certain pressure, the pressure of the vessel is going to determine how much breakdown you get. So that kind of helps with the glow mode, arc mode stuff.
Well,
say that law one more time. What's the law called?
Paschen's law. Paschens, I think. Let me see if I can Google it.
Paschens, I got it. Boom. All right.
That's kind of what they were modeling on the Sapphire project, because they were using Paschen's law.
Yeah, probably.
Who's driving, by the way?
So this is like people are real familiar with neon signs.
Not me.
Go ahead, Rich. Sorry, Chris. Go ahead.
The coffee. People are real familiar with neon signs, which kind of illustrates this chart. So neon signs are filled to like the bottom of that bell curve for neon, which makes it the most easy to light and the most efficient.
Right.
And then as you put more neon into that sign, it's going to get harder to light and draw more current once it does light. So if you look at neon signs as being on the very bottom of those bell curves, then like plasma lamps and like Tesla balls are more like halfway back up to atmosphere. And then that's how you get that arc mode, is you got to just put more gas in there, and then it becomes more conductive, and then it all of a sudden will just go to arc mode once the current's there, I think, kind of.
Well, that's exactly what it should do with the curve that Richard brought up earlier, is that as soon as it goes from glow to arc, you can see that large steep decline as the amperage goes up. It filaments, and I've seen that in your work where you have a glow mode going up the middle of one of your objects. I don't know who's driving, but you can go there to look at that. But it was that wonderful one that goes up like I'm not sure if it looked like almost like a pumpkin or something, and then it divided into like 16 or so or 12 tendrils that went like as it went into arc mode up at the top. I thought that was just a beautiful piece of work.
Thank you. I'm not sure which one you're talking about. If you go to the Ank's a really good example of that, because it has a wide base and it has the glow mode at the bottom, and then it constricts into a smaller diameter, and then that makes a really hot arc through that section, and then it refilaments and fractals and branches back out at the top sections into the two arms around the top piece. So that's like really what I'm going for in most fills, is to get a good visualization of both of those effects. And then it looks the coolest to me, in my opinion, anyway. And then that's kind of the theory behind like the sconces that I was showing behind me here, is they have that long, smaller section at the bottom.
Right.
And then slightly bigger volume at the top. And then that way you get that really hard arc coming right out of the electrode. And it has a chance to kind of fractal out into the top of the lamp a bit more. And then you get all the really nice feathery looking stuff at the top.
Basically, it looks like you're imitating glass flowers of electricity.
Yeah, thank you. I like that idea. But it's the vessel shapes really determines the plasma effects. Like if you just take a very small ball, it's hard to get arc mode and glow mode because of just the vessel shape. You almost need to get a big shape and then a small constriction and then a bigger volume again. So like some of the new ones that I've been doing that just look like hot air balloons,
right?
Where it's got a wider base and then a constriction and then like a big bubble on the top. It's kind of what I'm chasing to do that, because now it's helping that constriction and you get that really hard arc, and then it has a big volume to kind of fractal out in, and then you get the coolest feathers or petals like you were saying.
Well, that's and obviously in your line of work, the goal would be to make something as impressive as possible. One of the
balance with the lawyers though.
Fair enough.
There's the whole liability thing we were talking about before, and that's what. So like everybody knows, you can get a plasma ball for $5, but it's 5 watts. So it's kind of like stereo amplifiers. We were talking about stereos before.
Oh,
like you can
clearly,
yeah. You can get a 5-watt amplifier for $5 that'll drive your speakers, but that doesn't necessarily make it good. Right? Or you can get a 200-watt amplifier that'll blow up your speakers. So it's totally trying to find that line between getting it to light really easily, because if you need 30,000 volts to light it, it's going to be a hard consumer product, right? So keeping the pressure low enough that it lights easily, and then keeping the gas mix right so that it doesn't draw too much current, and then having the right driver so that the conductivity is good. So like some lamps, if you put too much, like if you fill something with too much xenon, it's you got a 0 ohm resistor in there, versus if you put neon in there, it's 1,000 ohms minimum. So it's kind of like a resistance, like we were talking about with speakers. Like you put 2 lamps on the same driver, it's just going to pull twice as much power out of the driver until the driver quits. It's not the lamp it's the amplifier that's making the power. So it's just an exponential thing, right? Where to get like.
But I would be thinking some of the things you could do.
Pieces, there's quite a bit of juice going into there. So if you touch that lamp on the bottom section where the real flashy xenon is,
right,
you'll get a 3/4 inch of corona off of it into your finger. Versus if you touch it on the very top section, there's nothing left. You can barely even tell that it's drawing sparks.
I see. So I see what you're saying.
A diminishing. It's like a kind of like a voltage divider kind of situation.
Oh yes, no, I see what you're doing. But this is just, I mean, obviously because you have that ball is acting like a capacitor in the middle.
Yeah, it's kind of like you got 3 capacitors hooked up in series to each other. So the DC can't get through any of that, but one will couple to the next one, will couple to the next one, will couple to the next one.
Right. So
I kind of cheated a little bit, and in the bottom I got some water between the two bottom sections. Like the dual lamp fits into this little cone sleeve in there.
I got the idea. Yeah, okay.
I filled up that section with water, which makes it draw a little bit more power too, but the water helps it couple to the next lamp. And then by the time you get up to the neon, it's really low pressure. And by the time you get to the very top one, that argon is at the same pressure as like a neon sign. So it's not going to do any crazy cool arcs, but it lights at the top of that thing. So it's kind of tricky to get the whole thing to work.
One of the things I thought that was really pretty amazing was when I saw them actually use a Tesla coil to play music.
Yeah.
And if I'm not mistaken, it was the Super Mario Brothers theme or something like that, which is appropriate just because of the sound. because 8-bit. But still, I was wondering, with that row behind you, and I noticed that they were all different shapes. Were you trying to do something like that at the beginning?
Sorry, which row?
Those long tubes that are up behind you, that I said that would eventually sort of look like flowers.
Oh, the sconces.
The sconces.
I'm just trying to make.
Because I just noticed they were all slightly different. I was wondering if you were making them for a particular resonance. That's just my thoughts.
Oh, no,
and then you could make music with them.
I'm trying to get, just trying to do as many fills into the same shape as I can to get a kind of better understanding. Just trying to take more of the variables out. So like I've been just filling random different size things, which makes it fun, but hard to predict anything. So I wanted to do like 12 sconces that are all as close to the same shape as I can, and then see how many different effects I can get by just changing the gas pressures. So all those sconces have different gases and different pressures in them, and then most of them are just getting driven off of the same driver. So like the ones you're looking at now, the xenon ones, those runs on like 25 watts, super easy to run. They run on the cheapest driver that you can get commercially, and they don't get hot at all, and they'll just run 24 hours a day.
I gotta tell you, every time I see these things, I have like Donnie Darko flashbacks. Swear to God, I'm just seeing Frank's ears. Like, did I just?
Oh, that's the one with the crazy rabbit or something, hey?
Yeah, like that's what I'm seeing.
What
like,
you're talking about?
Just Jesus. That, and of course, then you get the stomach worms. I mean, I still wonder what screwed me up more, Donnie Darko or David Lynch's Eraserhead, but I'm still going to go with Eraserhead.
I'll take some notes here.
On movies to mess me up? Yeah, I'll give you a list.
Yeah, send me a list of movies to watch.
Yeah, but not all at once. You have to take time to digest each and every one of them, and then back up and go, what the heck did I just see?
It'd be a good change. I've been watching documentaries.
It's like Fight Club, but shh, we can't talk about that. But his name is Robert Paulson.
Oh, I love Fight Club.
Shh. The government. Shh.
Right. What kind of coffee table really defines me as a person?
That is so true. What amount of electric bunny ears defines me as a person?
What voltage do I want to be perceived as?
Everything's just a copy of a copy of a copy.
Right, but it's a balance to get stuff that I'm comfortable putting out there. So like I got way more lamps than I actually have listed on my store, because some stuff just runs real hot, takes a lot of power, and I'm like, I don't know, I probably have to make some kind of user manual, like how to not. Right, so like if you take a Tesla ball, a plasma ball, and you put a piece of aluminum foil on the top, you can draw little arcs off of the thing. If you put a piece of Kleenex under there and then you touch it, you can start fires. And that's on a 5-watt plasma ball. So you can do the same thing with all my lamps. And I'm like, if you understand that, it's not inherently dangerous. Like compared to a butane torch, which, you can just directly.
Wait. Here it is. It's George Carlin. Excuse me, ma'am. Hi, I apologize. I don't mean to be, I'm not incredibly mechanically inclined. Did you say place the flap inside the metal buckle or place the buckle over and around the small metal flap? I apologize. I do not possess an engineering degree, nor am I mechanically inclined.
Right? So yeah, where I'm at now is I'm like trying to figure out how user-friendly I have to make it. So like I kind of offer my lamps, and then you got to get a lamp and a coaster and a driver and put it all together. And I'm like, I think that is scaring a lot of people away, because it's like
I think the easiest thing to do is if you really want to make it easy, like to do some of this stuff, especially if you're selling it to people, like say at a like someone at a concert or something, like that would be something that you would want at a concert or something, like like those type of things. All you have to do is make sure that they are completely encased in plexi on all sides. Like, I mean, buy by a fair distance, like the safe distance. And, you know, I mean, it's not exactly like these people want to necessarily, I mean, stuff like this, which is not so dangerous, it's that I can see that's induced coiling from the bottom, but not nearly as dangerous as, say, some of these other ones.
Well, I'm just like, the way it, like, there's just a lot of ways that you could do it wrong. Like if you get a driver and you just take the high voltage lead and start poking your buddy with it, like that's dangerous. But I'm like, are people going to do that? I hope not. You know what I mean? Or you could take the lamp off the coaster and put a bunch of metal on there and then start poking it with screwdrivers.
The first thing, well, yeah, but you know what? They still let TVs get sold.
Right?
Now, you know what I'm talking about. Who here knows how dangerous a real television was? Like, I mean, the microwave itself, yeah, that's dangerous. But I mean, that's just a time bomb. You put metal in that, boom. But I mean, those televisions with the CRT monitors. I mean, if you touch the back of that thing, I mean, it would stay, that flyback transformer would kick that thing up. Basically, William Amonsosa's kind of work defines that sort of vibrational thing that sort of kicks up the voltage with the magnets and the inductors. That's basically what this kind of sort of a flyback transformer does, because it doesn't work the same way as a regular transformer, but it can kick up to high voltages. And just touching that converter thing is just, I mean, yes, kind of like a boost or buck converter, yes. But if you touch that thing with a screwdriver, I mean, you're going to go right across the friggin' room. I mean, and here's the tree of life, by the way, in case anyone would like to know what the roots reaching heavenwards look like.
It'd be nice if I could use those TV flyback transformers, but they all got diodes hidden in them. So they're all pulse DC, which doesn't help me at all.
Well, why not?
Because you can't get DC through the wall of the glass. So you'd have to go into electrodes.
No. Pulse DC is not DC. Pulse DC is just above zero. It's still AC.
But your output on your flyback transformer is DC. Or on the TV ones for sure, anyway.
Oh, well, okay, yes. I suppose you'd have to, yeah, you're right. You'd have to cut off that last little piece. You're right.
I tried to use those in place of the AC transformers that I make or use, and it doesn't work. Just lights up the lamp weird.
You know, you could, well, some of the things you could, I mean, just the things you could possibly do with this type of stuff. I mean, just looking at it alone, I mean, what you're creating, and that they are so mesmerizing. I mean, this kind of reminds me of areas of catastrophism when there was things like this going. Just imagine this about, you know, a few hundred times slower, but going between planets. I mean,
yeah, that's what I'd like to get to. Is to reproduce the dragon that they saw in China and whatever else they saw and wrote down. I'd like to figure out a way to make the squatter man inside a lamp, but I don't know how to do it yet. I think I need some kind of or some kind of magnetic.
I'll tell you the problem.
To pinch the center.
The problem is, as I've explained it, your question was the exact same as David Brown's Electric Universe Eyes, and he had the exact same thing. He wanted to do exactly that. And the trouble is, if you go read, I guess it's called something like Petroglyphs in Ancient Antiquity, High Aura, something or other by Parad. I can give you the links for the papers. But there's two of them. But the thing is, he shows you the machine he used to make these effects at 2 inches across. And the reason they are repeatable is because of the current. So the amount of current that he was dropping across this, these are usually made, the machines are usually made to generate radiation on the gamma rays type radiation. Like, you have to be really, really, really far away from them, like filming these things through something very, very far away. So the problem then becomes when you're making them, they make repeatable shapes, but if you noticed, if you look at the little figure 1 type of description of it, it says 1.3 mega amps. So that's what he dropped across it, which is, I mean, human beings. We none of us are going to. I can't think of a way to make 1.3 mega amps without using a lightning bolt. You know what I mean?
Yeah, that's the part that loses me. Is if that. So, do you know what vessel or what was that Squatterman image captured in?
Oh,
was that
yes,
just
I do.
Air, or was it in a vessel that was low pressure, and what gas?
No. Well, what they did is they used basically. I think you might be able to look it up there. Who's ever driving? It's I think it's basically look up at like JPL Labs or Los Alamos Labs, and they're called basically something to study gamma rays. So put that in there or something. And giant machine, that might work.
Well, it's called the Z-Pulse Power Machine.
That's what it's called? Thank you.
Z-Pulse Powered Machine.
Okay.
Yep.
Z-Pulse Power Machine.
And Sandia has one too.
Well, basically, you're running in the terawatts range for these things, like 2 terawatts, and then of course they were really happy when they could hit 8 terawatts.
And what's the discharge in? Is it in atmosphere or is it in a?
Well, they use a metal. They use a metal. Usually, they use a metal wire, a very very thin one, to begin the discharge. But that's it vaporizes, and if you notice that the time frames are all written in n seconds, that's nanoseconds. So these things are listed in billionths of a second. So because that's how much they're dropping all the capacitance straight across it. Basically, you're just dropping the cap straight down. Now, this is not the right page, by the way, but look at
just it all through
look at images.
Yep.
Images for Z-Pulse Power Machine or something like images. You'll eventually find across one. Put Parat's name in there probably, because when I found it, it was like I realized that that's a person standing beside it, and it's bigger than this building that I'm currently in. And well, look at what we found. But the actual it's basically surrounded by all of this material to prevent it from irradiating everybody, and they must step back, and they use a what's it called, a fiber optic cable with a lens on the end to collect it like 3 rooms away, because they can't go anywhere near this thing. It's as big as like several cars of a rail car, like as big as that or more.
Well, if anyone has any ideas how we could scale this down, 100-watt version.
But that's the problem, you see. It's not the watt. You see, that's the problem. It is the amperage that you need to simulate, and there's no such way of simulating amperage. Amperage is amperage. I mean, all they did, like the Aurora or whatever, when we saw the Squatterman, was just operating at a very. It was the same amount of amperage, 1.3 mega amps. It just happened to be really big. What he was doing was really small, but it was still 1.3 mega amps. Like, see,
I kind of see amperage as the amount of voltage or dielectric potential that you just destroyed or let go, or not. I shouldn't say destroyed, but converted, I guess.
Well, so what amperage really is,
and then put it all into current instantly until your voltage is gone. So it sounds voltage kind of more like a ball lightning or
No. It doesn't. Not exactly, but it is sort of like if you think of voltage as us stretching a string between 2 points. That's one thing, but current is just flow, and the flow that is going through this thing causes it to interact with itself and create these wonderful steps and so forth in the toruses and all that wonderful, and the high synchrotron radiation and the gamma rays, those type of things. Those are extreme amounts of amperage that are causing it to interact with itself. You're seeing a low power version of that here, but you can see it is still responding to the heat. The heat is causing it to rise. Every one of those arms are rising because it gets hot and the air rises and so forth. But I mean, at the point where at that 1.3 mega amps level, there is not, the heat matters not. It doesn't matter. The amount of power you're putting through it is holding everything in place. Like, and that's just stupid amounts of power. So, yeah.
Well, Neil, what I'm thinking Chris is kind of asking for advice on is how to build a chamber, a vacuum chamber, where he could maybe put two globes inside there and arc discharge between them to recreate the dragon.
That would be, you know what I would probably do for entertainment value alone, because it would probably be easier. And because of the fact that you would know what you would get, I would get a piece of cat skin and glass and get the other one using rubber and whatever the other material is that you have to rub on it, silk or something, and make two oppositely charged Van de Graaff generators out of salad bowls or something. And that way you could just basically keep on pumping out the air and pumping in the gas that you want until you get the effect that you want. And you know that one is positive and one is negative, and you're really doing nothing except for basically spinning a small motor. I mean, just an idea.
I'm not too versed with Van de Graaffs and static systems and such. I'm more into the AC stuff. So I would think to get that dragon, I'd want to do like a bipolar coil.
Well, first, if you're gonna, you need a really powerful bridge rectifier, because you really want to go to DC. Because basically, if you ever read Lichtenberg himself, his actual papers, you can see what a positive strike and a negative strike, like he did all this work, like thank God he did many years before, and each one's completely different. Now AC obviously is doing some amazing shit, and we shouldn't be knocking it. I mean, it allows us to have frequency, and we can have resonance and all these other wonderful things. But at the end of the day, if you're going to try to do that particular image, you need a positive anode and you need a negative cathode to do that properly through to make it flow, because it needs to go from point A to point B. That's just what the dragon is. The dragon is different on either end. In fact, on one, if you notice in the Chinese version, the dragon is going for Mars with the red ball in its mouth, and its teeth are wrapped around it, and you can see the torus of its eyes. And then, of course, it's doing that writhing thing that they do. So, anyway, just an idea. And someone's clicking and clacking. I can hear them clicking and clacking.
Yeah, and somebody had a video now. They actually went to a Z-Pulse power machine and gave a demonstration. And they went into a room and they shut the doors.
Hey, Cronus
and
is
they
on.
turned
Cool.
they turned it on for like a billionth of a second or whatever it was, and it was like boom. I mean, they shook the whole facility. Like, yo, that's high pressure, serious business there, and it's like, whoa.
Well, that's what I mean. It's not something you can fake. I mean, you can fake a lot of things. Like someone said, well, that's where 0.707 comes in, or basically, if you want to do RMS, you know, you basically work it out to be what is it in root mean square, or basically AC to DC, which is basically you're measuring the power under the curve, is what it's called. So that's how much power is actually happening. It's the power under the curve, and if you cover that in with a pencil, like a crayon, that total amount under the sine wave curve, if you lowered it down and filled it into the spot beside it, would be 0.707 of what the original number would be. So that's what gives you your 110 volts, but it's really actually the voltage of a regular plug is actually more like 360 volts, 380 volts, something like that, like point to point. So when someone goes, I have a 10,000 watt RMS whatever, well, no, you don't, because you have RMS, sure, but if you don't know how to reconvert that into sine wave, you don't understand the potential between the 2 points. Someone was saying to me, it's only 20,000 watts. And I said, dude, it's 20,000 watts RMS. If I go and then convert, or 20,000 volts, sorry, RMS. If I go and convert that, then you're getting 42,000, 43,000 tip to tip. If that touches you, you're dead. Like, you know, it's, you gotta know what you're playing with sometimes, you know what I mean? But clearly, you're creating something at a lower pressure, and look at that. Look at it almost looks like a jellyfish, doesn't it?
Well, again, that's what I think he's trying to reproduce,
like
is
life.
those arcs that look like a dragon between two objects inside the vacuum chamber or inside the glass that he's blown. Sorry, I don't mean to harp on that.
No, but you could actually, anyway, I think all we need to do is get someone to donate you a relatively powerful bridge rectifier there, son, and you could have a lot of fun.
I got some bridge rectifier. I don't know if you guys saw, I did a video, I made a lamp.
Oh my God, I could look at that all day. Look at that.
By Jacob Gable there to make some craters.
Oh yeah,
I don't know
yeah.
if I got it up there, but
that almost looks like
that one, and I put DC through that one to try and make some craters into some sand, and that seemed to work okay. But it totally took out my camera, and you can't really see it or anything. Is there? I don't know if there's a video of that.
This totally looks like it's actually chewing up a mountain. Look at this, at the bottom here.
Yeah, it looks crazy.
The hourglass actually has a little bit of phosphor in it, so it has that extra purple glow on the glass
that's sick.
Extra from the UV. So, like, you know how argon neon lights work, is that they dope it with
I just realized that you're pouring sand down that.
Yeah, It's actually crushed glass, but same thing, kind of. So
isn't that all sand, really?
Well, I have a feeling if I go outside and get some dirty sand, then the lamp won't last because of gassing and contamination and whatnot.
Of course.
I figured I'd just use clear crushed glass. Then it's something I know what's in there. Yeah, and that's the other thing, is you got to get all that air out. Once you have any oxygen in there, everything just runs silly hot.
Something that might be very entertaining, and this is. I don't know if you could look this up. Who's ever driving? Is Robert or Krista? Krista's driving.
I'm driving.
Oh, okay,
I took over when I got back.
Why don't you look up sulfur on fire? There was a sulfur spill, and just a new page. Yeah. SULPHUR, and it was like spilled on the highway, and you could see these fire tornadoes, and it's a really good video. And I because of the way that it behaves, and then I put that particular image into my presentation because of the way that it will bore through a particular area, like one spot, it will just burn through. So go to video or something, or I don't know. Yeah, it was a hot liquid. Yeah, videos. Yeah, go ahead. Sulfur spill. And it's like it was at night. I don't know, but let's see what happens here. Okay, I don't care about your stocks, douchebag. And nor do I care about Mr. Buffett, or Buffet, as we would call him here. Okay, that's just, it's not on fire. Sulfur spill on fire.
Here, so
put that there. Here. Yeah.
Yeah, sulfur spill.
On fire. It was just, there we go. Anyway, this blue hellfire. That's a good way to describe it. Yeah. So look what this sulfur does. This is just in the air, okay? So it's mesmerizing and toxic, of course. But so you know what? No, I didn't suggest you do that. In fact, don't do this at all. I apologize. Don't do this at all. But if you do, I'll be very impressed. But I'm telling you not to do it. So
well, you're Have you seen videos where they put all these different chemicals on the top of their Tesla coil and it makes all these different pretty fire colors?
No, and I probably worry just thinking about it right now. I think we might have to go to the.
You should watch it. It's good.
We might have to go to the YouTube version of that. I think. Yeah.
Yeah, I'm doing that.
Yeah, I think
you just put
my computer's been slow lately.
Don't worry about it. It's just because they're embedded in videos and they suck.
Yeah.
And look at this. Look, who is this Chris Burak guy from? I've been watching 3 pages now, and he just keeps on popping up. Oh, that's us.
I sent you a link there.
There
Neil,
it is.
To that.
Go to the top one.
The only DC lamp I did with the craters in it. I sent it on Facebook. I don't know
there.
if you can.
Now, no. I'll see your lamp in a second, but take a look at what this friggin' shit stuff does. It's creepy, like the it just, this is in oxygen, like, you know what I mean? So the way that it could
yeah, they had to be in hazmat suits around this just to film this stuff.
Oh, clearly.
You couldn't breathe that stuff in.
I mean, no, you couldn't breathe this. No. Yeah, it makes people too. But see what I mean by the
There's
towers?
Fire tornadoes, yeah.
That's what and that's natural. If you want to, with just a simple magnetic field, I bet you could do that with a joke just by creating a pulse magnetic field around it, like around the like you sort of clamp it around the throat of one of them. See what I mean? How look at them go.
Yeah, I've totally thought about trying to incorporate some sort of DC electromagnets by just wrapping a coil around a section of glass tubing and seeing what effect it has on the plasma. I don't know too much about electromagnets yet, though.
Well, the electromagnet will basically, if you think about your current that is going up the tube. So let's say you had so many watts going up the tube. So you know the voltage, so you know the current. Okay, so let's say hypothetically you had 100. Let's say you had 100 watts that you're going through it. So you know that number, and you know that you're running at, say, I'm going to just pick a number of 10,000 volts. That means that you know that you're running at basically the inverse of those two numbers, and you're going to be running at like something like what 10 amps, or probably not even that. Or sorry, I'm even wrong there. 10 milliamps. So you're like right in the you're basically, you can calculate that very quickly. The point is that the current is light, but then you could do Ampere's law, and you could determine right around the throat of that thing how much magnetic field pinch is occurring at that point. And then you could affect that magnetic pinch by, because you know that you can calculate that into Teslas, and then you could use your own electromagnetic electromagnet to affect it. I'm seeing it paused at the moment. What are we watching? Sodom and Gomorrah, Ancient Star Wars, Uzbekistan, and Fire and Brimstone? That looks like Andalusia. Is this who is this? Who are we watching? Who made this video? Because I'm very interested. Chuck Hopkins. You sneaky git.
It'd be fun to try and make some fulgurites one day too.
This is the one where she starts to make the fulgurite. She shows the fulgurites that are like chimney stacks.
Oh my god, yeah. Oh, by the way, I did manage to find those again. You know those ones I said, here's a bunch of clams that were hit by a fallen power line?
Yeah.
And turned into a giant fulgurite? Well, I found all those pictures again. So
nice.
So basically,
you gotta post those.
Well, that's the thing. When I found them, I was like, oh, snag. So I'm going to include them into a video, just to make sure they're there for posterity. It's
right.
So, you know, because it's clear that these things happen. I mean, and some of the stuff.
But here's where they're showing the sulfur. That's like when they said that fire and brimstone ran down, it was sulfur.
It's
There's
very
this stuff, and they
white
said it burns.
sulfur. It's not like regular sulfur. It's very white. Yeah. and they're globules of sulfur.
And watch them burn it.
Yeah, because that's what I want to smell.
Right.
I've been to Iceland. I've been to a geyser. They were like, "It's a geyser. Enjoy it, guys." And we were like, "Oh yeah,
it smelled like ass."
No, but we couldn't smell it until it went off, and then it rained down fucking rotten eggs all over us. I apologize.
Oh.
Fracking. Did I say fracking? I said fracking. Anyway, so yeah, I was none too impressed with those fellas. But look at that rock. It's very pitted.
Right, and that's almost about to say right by the that uvula, dragon's uvula by in Three Fingers Canyon, where we were all those petroglyphs. Remember that like creek bed that was all etched like this?
Oh no, I have footage of that. Of course, yes, I remember.
Oh yeah, but it's almost very similar.
That's actually the very first video I ever made. There you can go. Yeah, way back, the Arc Blast Geology Tour. But I'm gonna have to try to make that better even. But I mean, included into this thing that I have, because I have all this footage from Bath and the symposium and so forth, and there's a lot of James Burkean ideas that I'm having there. So what the heck is this? Is that
the Alberta Badlands there?
Yeah, did you notice that?
Yeah, I've always been wondered by how the water made those fractal burns in the rocks like it did.
Water made fractal burns. I like that.
Right.
It made sense to me until I was like, oh wait, yeah, this.
Well, I haven't put
you fly up in a plane and it's like, well, it's flat except for the eroded part. So like where there must be a hole. I'm like looking for the drain where the water like went down all the fractal burns, and then like there's no drain. So it's I don't get it. It should be a lake.
Yeah, I cut down my presentation there. We had well, I guess it's not really jinxing because I know that he's very keen on dropping by. As you know, we've been we have a contact with Chris Dunn there, and that's nice. And we're trying to get Brian Forrester to have a chat with us too, and see where we're going there. But because of the archaeological talk that we'll be doing, I figured I'd just mention that. But so I had a very good opportunity. CK, you're here. So Chris, how's it going? Not Chris Burak, but Chris Kelly. Are you there?
I'm doing my best.
Well, no, I know who you are, Chris Burak. I mean Chris Kelly. He's still muted. He might have fallen asleep. So we'll just pretend that he's okay. And I don't know what you're doing there. Apparently you smoked that Cuban cigar a little too strong. Oh wait, we're in Canada. Yeah, I don't care. So anyway,
it's over. It's good.
So anyway, I was going to get Chris to tell you, but the point is that oh, he's here.
I was watching on YouTube, so I was a little bit behind.
Oh, now you realize we were talking to you. Okay, I like that. Hey, I'm on a live show. I might as well watch it on YouTube. You know the strange thing that you just said in your head, right? Sorry.
Hey,
I'm just laughing.
Imagine what I've been going through, Neil, for the past, 2 hours now, 3 hours. I've been looking at multiple screens. It was making me crazy.
Well, as long as you don't have to deal with two of them. Because now we got rid of the Twitch one, because apparently everyone loves the one here. So anyway, Chris, all I wanted to say, Mr. Kelly, was number one, thanks for being here. And also, you were there when Andy and I basically. I finally got a chance to show my presentation to just a few people, and one of them was Pierre's, and how the situation. By the time me and Andy were done with him, it was nice to see his affirmative reaction. I don't want to brag. So I was wondering if you could say what it was, or at least how things were, basically.
He was really impressed. I don't think he'd heard some of these ideas, and you were showing him the evidence right there, and he could ask questions. I was there too. It was great to be there and be able to ask questions to you guys as you went through it. It was very helpful.
Yeah, I basically did a trimmed down version of the presentation that I did for most of you earlier with regards to the like voltage is depth, current is width type thing, and deposition and so forth. But I cut like 20 slides out, but I still got a really some really good damming, like the rivers that crossed each other. I think
the parallel rivers were really good. Well, they're 90 degrees. Like,
yeah, because that's how water works, right? It would be as complicated as asking Chris Burak here to go ahead and try to make two currents cross each other and not mess with each other. It would never happen.
Well, maybe.
Well, maybe. You've a better chance with electricity than you would water, for sure, though.
I think God could do it.
Oh, well, thank you. I believe that also that aliens could do it. I also believe that, let me see.
Yep. I think
Superman
you're 100%
could do
right
it.
there.
Captain Marvel could do it. Thanos on a
Green
good day.
Lantern could do it too.
Okay, look, we don't even talk about that movie. We just refer to him as Deadpool and move on. Okay.
Oh, I love
Green Lantern. You can just go die in a hole. Okay. I'm just kidding. He's actually. It wasn't nearly as bad, but it certainly wasn't the movie he should have been in. He was born to be. If anyone is going to redo Ace Ventura: Pet Detective, it will be him.
I agree there.
Yeah. He's off the wall for sure.
And he was born to play Deadpool.
Oh yeah, clearly. God, love Wade.
Anyway, I can't wait for the next 20 years of Deadpool.
Next 20 years of Deadpool, yep. Until suddenly he's like, did you ever notice, by the way, if you watch all of the X-Men, you can see them in order at how much more muscle mass every time Hugh Jackman is putting onto his body as he's going. By Days of Future Past or whatever, he's like just like a roid machine compared to this lean whatever being chased by Brian Cox, as Stryker, as opposed to this younger version, and not the scientist Brian Cox, the really cool actor Brian Cox. Anyway, sorry. Are you back, Chris? Because I noticed that you ducked off screen, so I didn't want to. But
I'm just hiding, yeah.
Yeah. So Piers Corbin was obviously he very much enjoyed. He wants me to talk to him a bit more there and iron out a few things that were on his head. But I was basically just going over the static idea, like you were before, which is in a nutshell, basically going over formulas that are fairly static, very easy to understand, like. How can electricity lift rock off the ground? Well, here's the force holding it down, and here's the force holding it, wanting to lift it away. Do you see the disparity of the numbers? I do indeed, sir. Well, there you go. How can you prove the Earth is a capacitor? Well, you see how this is a plate, and this is a plate, and this is a distance, and this is a capacitance, and that's how that works. Like, it's just, it is what it is. So, Hugh Jackman. Ben Winter is like totally obsessed with Hugh Jackman, I see. Oh, really? He was? I didn't even know he was Australian. No, I did. But so, speaking of Australians you want to get rid of, how's Mel Gibson doing? Oh, that was a burn. I shouldn't have done that. I should not have done that. Oh, guys, I missed you. This conference was fantastic, and I can't wait to. I'm putting together some footage And I looked at what we got so far from the recordings. And Heather got some good recordings too. So she's sending me her stuff as well. And some of them were about things that I guess you could say would be totally Masonic in a way, in Wells Cathedral. Like, I think you'd really dig it. Like, there's a squatter man in Wells Cathedral. There's like every single thing is the correct angle for the planets and the orientation and watching out for Venus. You know, that kind of stuff. So Kelly can tell, if Chris can tell you about it as well. Like, I mean, am I lying, Chris? I don't think I'm lying. Am I lying? Jim would love it. I'm thinking Jim would love it because Jim likes the histories and the planetary motions, and there's like it's written in stone. You know what I mean? Well, or you can all just not talk like a bunch of buggers. So.
Well, Neil, so there were celebrities out there too?
Pardon?
There were celebrities out there at the conference?
I guess Piers Corbin is kind of a celebrity. I stood on King Arthur's grave, like I said. I thought that was pretty good.
I thought you said something different earlier because I was reading, somebody posted that there were some kind of EU hecklers that were in attendance too.
EU hecklers?
Hecklers or people that were opposed to the EU were also present too.
Well,
or people that don't necessarily.
Interestingly, one gentleman showed up for the first half of the first day, and then they went to find him, and his room was empty, and he was gone. So I don't know what happened, but he was gone. So that was.
I have a question from the YouTube guys.
Oh.
Kenneth just asked, explain why elemental crystals oscillate at different wavelengths. Nothing is synchronistic.
Crystals oscillate at different wavelengths depending on the length of the crystal and the flexibility. Basically, it's the permittivity and permeability of the crystal itself that allows it to vibrate when exposed to DC. The principle of how much compression or expansion it can have depends solely on how you cut it and how much current you attach it to. Like if you put it in, that's why you can use them at really, really, really small levels, like for a Timex watch, for example. But if you get bigger, well, there's some evidence that things like granite, for example, is extremely crystalline, and when you try to bend it, it creates poles, literally positive and negative poles inside of the rock. And it is these type of principles that I think the reason that we will never understand things like the ancients until we begin to understand what their world was actually like. And I think that they could do something with that we would, instead of building a pyramid to gain power or to do whatever we wanted to do, we would build Hoover Dam. And that's very true, because if you look around the world, there are so many friggin' dams, and all they do is make us power, and we suck so much energy to do it. So I'm of that opinion, but we're just starting that yet.
Got some interesting electrical properties. I got a big granite table as a workbench that I use that I never thought was conductive until I put Tesla coils near it, and it's might as well be a piece of steel as far as I'm concerned.
Well, it will, because all the crystals will transfer AC through it.
Yeah, and I can see the actual little grain structures in the granite all, I don't want to say glow, but maybe fluoresce or something, or you can kind of see the current path, but it's like not on the surface of the granite. It's like in, the table underneath the video that I'm playing right there, where I was smashing some stuff.
Well, you can go ahead.
It's very similar to the fractal nature of the lamps, or like when the lamp with the sand in it, where the current was going through the sand, looks very similar to that if you put a Tesla coil top load right on my granite table. I thought that was pretty cool the first time I realized that was a thing.
See, one of the things that we were talking about, that we've spoken about this before, and the reason there was some Russians who started studying the Osirion, I think it's called, where they basically had all those bull sarcophagi, And the bull sarcophagi in question had all, in the oldest pictures, had a bunch of square cubic blocks piled on top of them like bricks. And it made no sense. But what seemed to be the case is this gentleman deduced that if you threw hops and yeast and animal flesh or whatever into that thing and you sealed it up, it's hermetically sealed and it's made of granite, so it begins to bend. It has a 30-ton lid, and then of course they were piling more and more rocks on top of it to make it work when power got low, I think. And
like a pressure cooker.
Well, yes, but the trouble is it makes a positive inside and a negative outside. I mean, literally, it's just like a Van de Graaff generator, except it's made by pressure. So
I think I saw something about this, but and you're saying the blocks on the lid were used
to hold it down.
The lid sealed into the box?
Yeah.
To create a seal from atmosphere?
To hold it down. 30 tons wasn't enough eventually. Like, I think back when it started, when it was working, when they could move them, this was working fine. But when the world changed, they tried to get these things going again, and it was a much, much harder. And one of the things that strikes me is that this is the exact principle of the Great Pyramid, where you have two different chemicals that are poured down inside. The entire lining of every single passage is granite. And this thing is now suddenly has a positive core that's being held down by a mountain of rock. I mean, not just a small amount. I mean, literally a mountain of rock holding this thing together. And it has a negative outside because of its capacitive layer. I mean, I don't know about you, but just talking about it like that seems to me that this is a machine that was meant to do something. I can't tell you what it was, but I have some guesses.
They got to put the gold top load back on.
Well, I think it was Electrum, but let's not dwell.
Okay, what's Electrum? Electrum's
silver
like
and gold. Come on, you haven't played Dungeons and Dragons? It's worth half a gold piece. A silver piece is, you need 10 silver pieces to make a gold piece, but you only need 5 silver pieces to make an Electrum piece. These are all the rules of
10 gold pieces makes a platinum piece.
I mean, that's crazy talk right there, though. Because, I mean, if you have, like, platinum pieces, I mean, you're rich. You know.
I'm not much into crowdfunding, but I'd donate to something that was caused to put the top stone back on the pyramid just to see what happened. Maybe you just put the top stone back on and it starts working again. We can get some answers.
Actually, my theory is if I was to be I would do a few more tests first, but my ultimate test, if I was to be a betting man, I would probably go something along the lines of building a pyramid and putting it in the environment in which it would work at, using what we know has been removed from the pyramid. I mean, we know that doorway that they put into it, that hole that everyone sort of walks through now, is clearly not the door that was meant to be there. And no one knows why they did it, because how could they have guessed so perfectly? They say it's just a guess, right? That they guessed.
Oh, there's a lot of fishy stuff in that history lesson.
It's not hard to figure out, because once you realize the biggest thing that this is key. The biggest problem is this was about 950 or so, or 850 when he got into that thing. Ilbin San, or whatever his name is there. And now when they got in, the problem was, I think, is that they couldn't get whatever it was out. They couldn't get around the corner. They had to go down and then make a big 9-degree angle upwards to try to get whatever these things were out of the pyramid, the upper chambers that had never been explored before. Everyone had gone to the lower chambers. I mean, they've been going there for years, but the upper chambers were sealed because, of course, like we said, this pressure was pushing on these blocks. That's why there's 3 separate blocks that are so hard to push through. I mean, you could never push them through because they are trying to stop this pressure. Even if 1 or 2 fails, it still won't explode. You know what I mean? And that's what they think they were trying to do, because, I mean, this is a significant amount of pressure if this is the case. The entire thing inside of that thing would have been like 50, 70, 80, 90, 100, 3,000 atmospheres. I have no I mean, but we're talking about turning the granite into like a pure, like, I mean, a bent plasma. And that's why I think that they think that something was broken inside. They think there was an explosion inside of it because they say that the walls are pushed out 1 inch in every direction. I think that they were pushed out 1 inch in every direction, but there was not because of an explosion, because that's what it did. And I think that possibly those things that they removed were tuning forks or type of things up that main shaft, which is why they were too tall to actually get around that corner. So they had to dig a new tunnel to get them out. And that's what I think he did. And because there's been rumors that there's giant tuning forks sitting in a museum basement somewhere. So this is what sort of comes to mind. And I'm sorry for this giant segue, so I apologize.
This looks very Raiders of the Lost Ark-ish, I was just thinking. Like at the last scene.
Oh, no, not with the aliens.
Yeah, it does. With the when the Ark was spiraling up into the clouds, and then
okay, no,
just,
that's a good one. That's a good one. Yeah. Sorry, I can't believe that. I watched that whole movie. Like, I'm sitting there going, "This is the best Indiana Jones movie." I can even forgive the fridge. Okay, I can forgive the fridge. It's okay. I can forgive the fridge. I'm okay with this. Okay, because he fell from an airplane. He still lived like on a fridge door or something. I don't even know how to do that. Right. But and of course, I'm okay with all this, Temple of Doom, but then suddenly I'm watching this movie and the alien thing happened, like when I saw the alien face, and I was, right. It was almost like I could feel my hands rise into the air and just go, done, and just walked out like.
Yeah.
It's like I wanted so hard. It was, I had a few of those moments when I was watching The Last Jedi. Especially when Luke died of meditating too hard. Like, Jesus Christ, I want to kill. I mean, I don't know if I would punch him if I saw the director of that movie, but I would throw a pamphlet at him. Okay, I'm just telling you. Like, he'd be like sitting there going, "My name is Rian, blah blah." I just throw a pamphlet at his face and walk away. Like, I'm not talking to you. You ruined my childhood. I don't have anything to say to you. Next time when your kids get older, do you know what I'm going to do? I'm going to fuck their world up. That's what I'm going to do.
We're still live.
We are live, apparently, and I should not have said.
So the first rule just went out the door twice.
I did it twice. See, darn it. Gosh darn it. I do not wish to swear.
I said it smelled like,
It's okay. We don't need to. We don't need to revisit. We're so sorry, YouTube.
No, I want to have you go on the upside of having more points on me on this one.
Guys, I gotta tell you, this has actually been really fun. I'm glad that we actually figured out getting this working, and it seems to have gone quite well.
It's just that the YouTube people that are watching might be disappointed if YouTube cuts us off if we keep swearing.
Well, actually, just so that everyone knows, the people who are watching live are getting to watch the live version of this show, but that is not going to be the final version of the show. As soon as this happens, it's going to go unlisted automatically, and then I'm going to take it and I'm going to go and turn it into, and cut out all that little swearing and all that jazz.
You editing machine. Right. You.
Well, it's just proper, But it's going to be mostly exactly what they saw here, obviously. So. Well, I didn't mean to cut the conversation short, but I guess we're doing great here. We've been talking for now 3 hours, so let's wrap it up. Anything that anyone wants to add? Anything that perhaps Chris wants to tell a story about what happened at the conference? Anything that was really memorable to him? Or perhaps anyone wants to ask us what might have happened there? Or perhaps ask, of course, Chris Burak if there's anything that he is currently working on, or Sapphire.
There's Sapphire because we were talking about Sapphire earlier, and that the new paperwork is out on what happened with Sapphire. If you could go over that quickly, Neil, with the people on YouTube so that they can get a better handle on it. I just touched on it quickly.
Well, no.
No. Okay.
I mean,
Well, ancient Chinese secret.
Well, it's not the secret. It's just, well, let's just say, I'll say it this way. Ito Cowell's model, presented by Edwin, of course, Edwin, and James Sorensen, was not only fantastic, but they also built a periodic table of the elements. And as such, they were able to show exactly why.
Was that released?
It was shown at the conference.
Because I have a copy of it. I'm going to ask him if I can share it. I'll probably post it later if I can get permission.
Well,
I was talking about the different the new information about the elements that were found. How many more there were?
So allow me to finish my conversation.
Right.
So, Richard. Anyway, so what happened was they were using a particular type of tip, and it got Moulinexed, for lack of a better term, and they went and got it inspected, and they found, they found things that would be indicative of, well, let's just say low energy fusion, and this seems to be merging very well with Edwin's work. In fact, Sapphire and Edwin are going hand in hand. And so, I mean, just in principle. And correct me if I'm wrong, Chris. You were there as well as I was. Anything that I'm dropping the ball on here? Mr. Kelly?
I guess it gets pretty complicated, but we should go into it at some point.
Well, no, just to general, anything that I was dropping the ball on there. I just was wondering.
You probably understand it better than I do.
Oh, well, you're too kind. But yeah, so it seems that because of the way that Edwin's model predicts the breaking of molecules at certain or atoms, nuclei at certain points, it seems that he can account for many of the variabilities and mysteries in this. So, of course, it didn't take long before a few people were already at the point where they were going, weak force doesn't exist, strong force doesn't exist, quantum mechanics, load of rubbish. What exists? Electromagnetism, period. And it was, now it didn't seem to, it seemed pretty bold at that point. But by the time we got to the end of the symposium and Chris was there, and it was Andy and I got a chance to, of course, do our wonderful back and forth as me and Robert would if we were present, you know. And
as we do,
and so you know, as good-natured people, we could, of course, agree to disagree because he was going on about something, but the end result is that then suddenly Phil popped up. It was just like a call, just like this call, and he goes, "Can you show him the expanding Earth?" And I was like, oh, "Okay." And then we're like dropping into this, and it was like. And goes, well, let me explain why this is a possibility here. Let me show you what electric gravity is like. And here I am trying to go this. And it goes, well, okay, this is what Wall thinks it is, but we also have to consider the Sainsbury model, blah, 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 and start going over. And then by the end of it, you're just sitting there going over we got to go over the dragon eggs and of course, climbing the chevrons and all that stuff. Everyone got to see that there, Robert. So that was really good. And some of our jokes and our little things, like when we were climbing up there, it goes, well, I guess if we fall down one of these things, no one's ever going to find us again, eh? And then I just went, hi, Mom. Glad for watching. You know, like so that that goes little chuckles and whatever. But we hit a certain point, and of course Andy was going right through because he was there with you, I think, before, or Bruce Laybourne, and they just ripped it was just because I had the camera right there, so he could just describe it straight up. And you were like hammering on that dragon egg, as it's called there, the Birkeland current and the stone. That was very convincing. And then of course it was like, well, can you tell me how some of these work? And of course, as soon as that happened, I was like, well, I might as well just show you my presentation, but I'll just go through it real quick here. And I was just going, and I go, so here's your depth, blah, 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 here's your width, blah, 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 here's your force powers, here's blah, 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 here's your capacitance model, blah, 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 here's a bunch of falsifications, here's Esker's and Drumlins, blah, 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 and here's how you like drill holes with fire tornadoes. And it's like suddenly his brain was just going pow, 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 pow. Like you could see the neurons firing like he has never fired before. Like this has been something he's never done. He's never had someone just sit down with him and go, and this is what the new paradigm's like. You like it? And the video, by the way, that video was a big hit too. People were like doing that whole like, oh my God, where did you get this music? This is it. Look at Alphane. Oh my God, blah, blah, blah. And then of course, Wal Thornhill comes up with his wonderful thing. He missed whatever he was going to say, but we saw people like Ev Cochran when he was like 30 years old. Like, I mean, I know Chris Kelly might not have known who some of these people were, but I mean, some of them to me, like Wal was smiling like in 1994, like I was meeting Wal, like I was smiling, like that's how young Wal was. He was just like me going, hey guys, can I hang out with you? Yeah, this is cool. That's how not that he was, just how it seemed, I don't want to insult the man. It was just.
Well, no, that's how I was when I was at the EU 2017 and just at OTF in 2019 here in February.
Actually, that's how Chris Kelly was. Chris is friggin' sitting there saying to me, he goes, "Hi, I'm Chris Kelly." Blah blah blah, and I'm like, "Yeah," like I'm Neil. It's like, right. You run the electric, yeah. Like,
but then again, I was standing across the table from Dr. Peratt, and
I know, it blows your mind.
It's like, and I just was like,
what? Yeah, I know, and I that's exactly what happened. Like the first time I ever went to an EU conference, I was wearing a suit the whole time. It's like, no, they might ask me questions. I don't want to look like common riffraff, But obviously now I got to know them as human beings, and it's obviously still. The idea of what has transpired there, I can't wait to get.
What is that?
What he's doing?
That
looks like an electric clamp so that you don't kill yourself. But
right on.
I don't know for sure.
That's a gun for heating electrodes in the kiln.
Okay.
So like these electrodes that the sconces use and neon signs use.
Okay.
If you only use one of them, you gotta process it with an induction heater.
Ah.
So there's a big power supply that sits here, and then I can.
I actually have a silicate in a phone here that's a sodium aluminum silicate called an alcium. It's a mineral. And we process it into like art pieces, but the ground up like powder and stuff, could that possibly be kilned into a glass?
I'm not too sure about making glass. I just buy the tubes from.
Oh, you buy the tubes?
The supplier.
Okay. Because I wasn't sure if you made the glass too, or you just buy it. Yeah.
Hey guys, have you been checking out YouTube? It looks like a few people are calling us out on our bullshit.
Oh yeah.
I know. I'm not sure. You can pick out who you think's calling out our bullshit. I have a couple names, but I want you guys to go and do that first.
Yeah, I already had dealt with somebody earlier. Like,
you don't have to deal with them. You don't have to deal with them. No,
I like doing that, Neil. What are you talking about, man?
Oh no! I didn't mean that. I don't want to cause anybody actual problems. I'm more teasing my audience, not as opposed to actually calling them names or anything.
I've been following it fairly closely, and what people are saying some things, and I'm offering some other options, and We're just talking.
Well, come on, you believe in God.
I
mean, come on. You're crazy anyway. Sorry, I'm just kidding.
There you go.
No, don't listen to me. I'm just.
Yeah, somebody earlier was saying we're parrots, and I don't know.
No, we are certainly conscious human beings. No one. Okay, parrots.
We're totally sincere in our sincerity.
Parrots that imitate things. Okay, if you imagine this parrot that's imitated me. Now look at the computer that's sitting in front of any one of you, and tell me that parrots imitating parrots over time would build that. Good. Glad we all agree. Moving on.
Electric universe.
That's good. That's good.
You can bet you're behind somewhere around the world. A parrot has said that phrase.
Chris Kelly, did I tell you the scary thing that happened while I was on my way back across the border into Canada? I landed in and they go, Have you been on any farms? That was the question.
What did you say?
Well, I was like, define farm. I said I was kind of close to the animals and I stepped over some cow shit, but I didn't actually touch any animals. The horse got close to me once and I kind of reached out to it, but I never really touched it because it didn't really like me. It liked Phil. So what does that mean? And he was like, "You're free to go, sir." like I was just, I didn't exactly know what else I was just trying to be as totally honest as possible. Like, I don't know how this counts. There were sheep and cows and stuff, but none of them came and breathed on me, so.
Yeah, I wonder what answer would have got you in trouble.
Well, I suppose if I went and milked a cow, I guess, or something like that could cause mad cow disease because you guys had that once.
If you went into a barn and had cow feces on your shoe or, things like that.
Well, that's what I mean. That's the whole, it's nothing. Just mad cow disease happened and it happened over here once because of a cow from there. So now everyone's all like, still, and I guess that's a good thing. I just can't imagine what they would have to do. Please rub this on the bottom of your shoes and your hands. What else would you do? Go see a doctor and get a shot for something or other? I just can't imagine. That's what I'm saying. Somebody on the actual YouTube channel is probably going to go.
I can honestly see them taking your shoes, leaving you walk barefoot to go buy another pair while they incinerate them.
That's good because these cost $20 friggin' bucks. So. So I'm going to get off lucky in my Walmart specials right here. Well, it's only because I hurt my back recently, so I was like, okay, no more tying shoes. I must just slide my shoes on, So, but you should have seen me. Some of the shots that you're going to see later as I'm sitting there, I'm using my cane to point at things. So you're going to see that. I get so used to it after a while. I'm using it to poke at things. Like I'm like, hey, tap, tap, tap. I'm tapping people with my cane. I'm like, oh my God, I'm turning into an old man. Just we were dancing. Me and Buddy and Robert were doing the Squatter Man dance, not just 2 years ago. And now I'm limping along like a wah. Anyway. Guys, it has been a fantastic time. Don't worry, it's just it's temporary there, Robert. I don't think it's going to be permanent or anything. It's just I need to go see my doctor. Yeah, well, it's been 3 weeks and I'm still like pretty messed up, but it's I'm not I'm out of pain meds, so I'm kind of whiny right now. So. Yeah. But anyway,
we're going to do a geology tour here soon. We got to go down because I found out there's some there's a shack down at Three Fingers Canyon somewhere in that valley somewhere. So we got to go find that and go check out.
There's so many things that we actually should probably be doing there. Andy can't come because it's too early. So. Right. It looks like Fitz and Laybourne.
Well, what we're trying to do is we're just trying to scope the area probably up around Dinosaur just so we can do like either a video tour because we're going to try to bring a drone up there and fly it around, because there's so much involved in that in their area, and it's close to the store too, so we can do like a quick tour, or if we were to have like a convention or something, we were going to try to plan like a bigger loop that would involve like the 9 Mile Canyon all the way down to the Capitol Reef area, because it just flows, and then we can come all the way along up the Colorado side on the way back and check out that. We're just trying to scope an area now, just to the plan a route, and then if we were ever to get like an area, like a geology tour, like a large one set up for everybody to come and get involved, that's for later on.
Well, it looks like we should be probably aiming for the American Northwest, if we can.
Yeah.
Because they advertised the next year is called it's called EU 2020, and it's called Vision, and it's apparently in Portland.
Okay. Vision, huh?
Well, and I guess, there was that big thing that happened at the end that Chris Kelly was there for, that had to do with that whole, yakking and people coming up with ideas, and it looks like, there's definitely a thirst for momentum in the coordination front, and a lot of people like-minded like ourselves who are here for the love of it might find that to be appealing, and so I've been mulling that over in my mind exactly. I mean, Chris was there, and you're sitting there, well, it looks like you're volunteering, eh? Ha 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 ha. And then I'm sitting there going, crap. I think I did say crap, and then I was like realizing what I got myself into. But you're thinking about all of what this might mean and how to approach it and stuff. So it's still gestating in my mind. So, as you can imagine, but we seem to have a great group of people here who really could use. Who want to help out, and I can see no better group of people who could potentially help out in that regard and bring a lot of people together. So it sounds like it's right up our alley, actually, in a kind of way. So
yeah, let's take on the challenge.
Well, we have to, because I was very stressed. I was very straightforward in saying that, coordination, not control. If you know what I mean?
Right.
Because I mean, who would want to bow down to anyone and say that you have to do something? But wouldn't it be nice if you can go, no, actually, this person should go to that conference. We should probably sponsor them to get there because they're specifically good at arguing against these people. We should help over those people. We should help make sure that these that we're educating through YouTube and through other channels and through other things like that, and you're not just leaving it to academia. I mean, we have to basically say academia is attacked with academia, and that Eastern religion is attacked with people who know Eastern religion. Mathematicians are attacked with mathematicians, physicists with physicists, astrophysicists with astrophysicists. Generally speaking.
Right.
And bring people together, because, I mean, I'll tell you right now, the thing that blows my mind is here I am looking at the stuff that Chris builds, looking like lightning in the sky, coming down, with, the fire and the brimstone of the gods, so to speak. And then I realize all of that is just but a hiccup compared to what some of the things that Jim has led me to now to realize that. And even when I was looking, I listened to the conversation, I am embarrassed to say that until I actually saw his hand gestures and what he was actually saying with his hands, did I not fully grasp what the hell I was looking at. And now I'm like, okay, I have to take this in consideration now. We're talking about a culture that goes, the pyramids? Yeah, that was one of our last attempts. One of the newer buildings we put up, type of feeling. You know what I mean? Those type of people. Because we're talking about a society now that spans on the other side of 550,000 years, possibly. That's Michael Cremo would cream his pants, like that's, like he's the guy that goes, yeah, 28,000 years. And we're going 550,000, dude. Because this is a whole different level of trying to understand about what the skies were like if there was actually, but it so makes much more sense, by the way, Jim, when I think about the idea of the crystal spheres and how there was the firmament of the crystal spheres at the very end, and then there was this other one that didn't seem to apply to any planets. You know what I mean? And then there was the planets. Each one had a crystal sphere, and then epicycles upon epicycles. But it was that other one in the middle that I was always like, why is that even there? And it's off-center to the rest of them. And then you just could walk over it and go, wheels within wheels, Argo, Draco. Got it now? It was just straight up. Just
mind blown.
Mind blown.
Yeah, that was dope. That was like, whoa, man. Whoa.
So
wow.
It is these type of things. We don't get a chance to see what we can do. But now that here we are, and so you sell these things, if I'm not mistaken, there, Chris, as well. I take it that you don't just do art displays with them, but people. I mean, I assume that they're. Do you sell them with power, or how's that work?
It's been kind of all over the place. I sell them. I got an Etsy shop that I have everything that runs on the 2 available drivers from Amazing One. So anything on my shop, you can buy a driver from that place that'll light it.
Okay.
And then I sold like 15 lamps in the last month here. I sold a couple to a shop that they're going to put in a window and try and run all day forever. I don't know how that's going to work. It's theoretically possible, but we'll see.
I hope you didn't offer warranty.
Well, it's the lamps will be fine. The only problem with the lamp is if you get it at 900 degrees, it'll slump. So I'm like, that's not going to happen. It's just the drivers. Like the drivers that you buy they're I want to say a cheap consumer product, but they're not I'd like to be able to do better. Let's put it that way.
Right.
Like if you run the thing all day and the driver gets 80 degrees the whole time, I'm like, I don't know how long it's going to last. You might be buying a new driver for $400 every year, which I'm like, I guess. So still kind of up in the air about that one, but some other people got some to run off Tesla coils, like some people that do not festivals, but like science exhibits or demonstrations or events or that kind of thing. And they're like, we run Tesla coils and we have these like fluorescent tubes that are kind of boring. So could I use that? And I was like, yeah. So that, and then what else? I got some guy that just wanted some stuff that he could play with and try and get to light with his own drivers he was working on, and some other guy that wanted a mug to take to Burning Man. He's like, I want that glowing mug. I want to walk around with it. I'm like, well, being able to walk around with it's going to be a challenge because you need a power source. But I'm like, so hopefully he works it out. But I think he's trying to figure out how to put some battery power.
Exactly how many D-cell batteries can you fit in your rectum, sir?
Well, it's not. The mug, the one he's trying to light probably runs on 5 or 8 watts. And I played around at first with like an 18650 battery cell into a little tiny Slayer circuit, basically like a self-oscillating single transistor that just turns itself on and off, like that box, the nothing box where you open it and it just closes and you open it. I love those things. Anyway, you can buy that little tiny driver. It's like the guts from an arc lighter. You know how they have electric arc lighters out now?
Oh yeah, just little tiny ones that you just light, you know.
Yeah, and it just arcs across like just wide enough to light your cigarette. But
Basically
I was like,
a spark
well,
plug.
according to Passion's law, if I take the atmosphere out of there and use that same kit, I should be able to light 10 inches of neon with the same thing. So I did those, and then made like a totally wireless or self-contained version where it was a 18650 lithium ion cell with that little tiny transformer inside of a glass tube, and then a single electrode going up into the piece. But it was relatively small, but so it's possible. I'm like, you can run it off a 18650 cell. It's just I don't know how long. Maybe bring a pocket full of batteries, solar panel, solar
I don't
hat.
know. I just picture something like this being worn on top of someone's headdress in some anime something. Like, I mean, just like.
Oh, I'd really love to be able to make a Magneto helmet and then do like a human top load situation where you just kind of I stand on the coaster and then I can just light anything by holding it.
You know, that should be your next audience, you see, because now that you have like all these weird superheroes from like all these Marvel and DC movies are going to be coming out now, there has to be one or two of them that are going to would love to make use of that in their costume. There you go.
It's definitely a different market. I'm definitely
Hey, cosplayers, would you like to be weird?
I was like, yeah, I know what they want. They want this.
Yeah.
Now I'm like, I'm going to try and get a...
Because that looks like two like beautiful, like artistic wings. I don't know who's
buying this stuff. It's all over the chart so far, yeah.
Well, I mean, there's something about it that, well, this is basically why the Electric View was formed in the first place, just so because it's like, what are you into? Electromagnetism, in what sense? In all senses. Like historically speaking, or astrophysically speaking, or geologically speaking, or nuclear speaking, or gravity speaking, or which?
Yes.
Yes.
Well, hey, I really appreciate you guys inviting me to the chat because I try and talk to normal humans about electromagnetism and plasma and ionization and resonant Tesla coil transformers, and they just kind of do googly eyes at me and hang up, right?
Well,
What's that?
We didn't get a chance to actually, I mean, I want to see, I mean, if you do come up with something like the resonance idea, I really hope that if I can get Jonathan Nava on to hook up his little doohickey there, because he's sending me the schematic, and so I'm going to go through it myself. But if his works, I mean, his worked. I mean, it worked. I can't say it didn't work. And it was powering a light bulb at a distance, and I could tell, you know, so I'm like, huh. So there I am, sitting there trying.
The definition of resonance differs by who you ask. But that's like the concept of the Tesla coil is it's a frequency-dependent transformer.
Well, the definition of plasma changes who you ask too, but resonance probably changes less. But, yeah. I mean, it's, I mean, to think that really, unless I can't think of a place that you can really get away from it. Like, there is snow, really dry snow up here, or dry sand, or smoke, all of which are a form of plasma. And then we've all seen dust devils. I mean, they're just right there. So I don't know why this is even, we should be, I mean, seeing earthquake lights, well, that should be a sign, you know. So, but I mean, things like that are why they're mysterious, because they don't understand how something's happening. Why are the rocks glowing? Why would an earthquake make the rocks glow? Do you understand piezoelectricity? Well, I understand that some rocks are piezoelectric. Yeah, but do you understand piezoelectricity? No. Then why the fuck are you a geologist? Sorry, I mean, why are you a geologist, sir? I did not swear at you.
Well, I think there's this weird thing where the world learned a trick about people, and if you get them to pay for their education, they own it better.
Well, I gotta say, I'm trying not to fall into that.
If you just give people free information, then they're more inclined to select and choose between which one they actually own, you know? So I think that was a trick the world played on people. They're like, here, we're going to tell you what to think, but you got to pay like 50 grand for it. And then people are like, yeah, this is absolutely the truth.
Yeah, no. The truth will be when they realize that it's not the truth. And then they'll be like, oh, crap. Yeah, I'm sorry, all you people who thought that people could live on Mars. Our bad. That just happened to be the very most expensive coffin you've ever seen. You know, or something like that. You know, and then you like realize your theory's wrong because, you know, people died. That's when you realize it. Or
you guys all think they made it to the moon here or what?
Oh, were we going here right now? Right in front of
I don't
live?
know how much time we got left. I kind of got to run off pretty soon.
No, not again.
I think it's a couple days till the 50th anniversary of Apollo. I was thinking about making a plasma rocket ship, but then I'm also being kind of
we do have
lazy,
to wrap
so
it up.
didn't.
But I'm going to tell you right now that my name is.
My name is.
And my middle name is Albert. And yeah, so even though I don't necessarily believe in that, well, what Albert Einstein won the Nobel Prize for, correct? But I'm not really a big fan of his relativity. But Neil Armstrong, well, I'm not sure if they went the first time. I'm pretty sure they went after that, though.
I don't get relativity at all. How do they know who's moving and who's staying still?
Because it's a bunch of BS.
Doesn't make any sense, man.
Yeah, Stephen Carruthers will take care of that for you right there. Just go talk to him. Just say, sorry.
Yeah, they use Mathemagic, and Stephen Carruthers points out their Mathemagic and their falsehoods.
Well, the problem is that math, no matter how intricate and amazing, really requires cause and effect. So, you know. Anyway, I thank you very much for being on here. And this was fantastic. I loved it. And I hope to see you guys again. And I hope that you do feel free to come on. We can have like up to 50 people now. So this is fantastic.
Well, thanks for inviting me. And
you're very welcome.
There's no technical difficulties with plasma.
No.
RF and stuff.
Yes, please stick around a little bit longer. Thank you very much. Well, everyone, thank you for watching the first live broadcast of Electric View. We're going to go ahead and I'll turn this into a show for you. I'll have it out as soon as possible. But I have one more person to get out first, but then this guy. Anyway, take care, everyone. Love you all. Bye-bye.
Take care.